Good evening to all the participants. Good evening, madam.
Good evening, ma'am.
I welcome all the participants to the second day of this faculty development program. It's my privilege to introduce today's distinguished resource person, Dr. Ashwini Kodipalli. Dr. Ashwini is currently working with the Indian Institute of Science, IISc Bangalore, one of the India's premier research institutions. She holds a PhD and has over 14 years of academic and research experience in the areas of artificial intelligence, deep learning, medical image analysis, biomedical signal processing, and healthcare applications. Her research work primarily focuses on AI-driven medical imaging, deep learning architectures such as CNNs, convolutional neural networks, and intelligent healthcare systems addressing real-world clinical challenges. Dr. Ashwini has published research articles in reputed international journals and conferences, contributing significantly to advancements in medical image analysis, AI-based healthcare diagnostics, and signal processing applications. She also has been actively involved in interdisciplinary research projects, technical training programs, sharing her expertise with faculty members, researchers, and industry professionals. We are honored to have Dr. Ashwini with us today to deliver an expert session on this AI applications in healthcare. Now I hand over the stage to you, ma'am. Kindly start the session.
Yeah, thank you, ma'am. Before I start the session, I thank the management of Srinidhi College for giving the opportunity, and thank you, Sujata ma'am, for coordinating the event. Yeah, so good evening to all the participants here. I'll be starting my session. Yeah. Can you please confirm, Sujata ma'am, can you able to see the screen?
Yes, ma'am.
Yeah, okay. Yeah, so let's start with the session. So I request all the participants, I know it's an evening time, you'll be busy with your, evening works. So if possible, just have a pen and paper with you because whatever I'll be discussing with you, there are few important points which I'll be telling you to note down, which will help you a lot when you carry out for your work. So I'm very sure the participants here more or less will be the faculty members in various engineering colleges, or we can have a research scholars here. So although the FDP is primarily focusing on medical applications, whatever I am going to teach you today, that is CNN architecture, I'm teaching you in general how CNN works so that you can apply this CNN architecture for any of your domain. But when it comes to medical, what primary care that has to be taken care, that I'll be discussing towards the end. So with this, let's get started. The entire presentation will go, I'll be covering the following topics. First, we will be, since we are dealing with the images, we'll be seeing some of the important fundamental concepts of images. Then we will be looking into the architectures of CNN. In detail, we will go into the various layers, how each layers are contributing for performance. Then we will see if there is a time permit. I'll show you the hands-on implementation of CNN as well, if time permits. Otherwise, I'll be then moving towards the standard CNN architectures. But before we go into the architectures, if you can understand the initial first two topics, you yourself will be in a position to understand the standard CNN architecture. So for the first 45 minutes, we'll be going into the general CNN architecture only. So with this, let's get started. Since the entire presentation is dealing with the images, I have taken, it is all with respect to CNN, where images are passed as an input. I have taken many images from the internet, and these images have primarily used for educational purposes only. And for this particular presentation, the following are the three textbooks which have been referred. One standard textbook, that is Deep Learning by Ian Goodfellow, and the second Stanford University's Deep Learning course, that is CS231N. This is one more important source where the faculty here or the learners here can able to refer to this. Then the third textbook, Deep Learning with the Python, if somebody is focusing more from the practical perspective, then third textbook is one of the good one. So although here I have intentionally put less images related to medical one, because I wanted to keep it as a general one so that every teacher, whoever is interested in your own domain, you can able to apply to this. Now, whenever we are dealing with images, at the most, we can work only with three different types of images. One, you can have a colored image, which is RGB. Second, you can be working on a grayscale image. And third, you'll be working on binary image. Apart from this, we don't have any other types. I'm not talking about the format here. Formats are n number. You may be working on JPEG images. You may be working on PNG images. If somebody is working on medical images, you may be working on DICOM image. Or if somebody is working on satellite images, live stream images, you can be working on TIFF. So I'm not talking about the formats. I'm saying that the maximum types of images can be either RGB, grayscale, or binary images. These are the three different types of images. Now, whenever we see an image, we, from a human eye, will be able to see an image like this. Whatever you're seeing on the left side, this is how you look at an image. But does system also see the image in a similar way? The answer is no, because how do the system see the image then? The system reads an image something like this. On the right side, you can able to see. If you closely observe, you are seeing so many squares, box kind. So for every of this box, there is a value, and that value we call it as a pixel. Therefore, for a human eye, it is an image, but for a system, each an image is being read as a collection of pixels. There are many such pixels which are being grouped together. So each pixel in an image is represented by a numerical number, and that numerical number we call it as a pixel value, which means here you can able to see many number of squares. For each of the square, there is one numerical value. And next important aspect that you should know when you are dealing with images is every image will have a dimension. When we say a dimension, it is a height and then the width. Here you can able to see. So this is called the dimension of an image, which is how many number of pixels are there, which is nothing but what is the height, how many rows, how many columns. So what is the height and then the width, we call it as a dimension of an image. Now, from the previous slide, we have seen the different types of images can be either in grayscale, binary, or an RGB image. So whenever, and each of a image is a collection of pixel values. We know that many number of squares, for every square there is a pixel value, right? So for a grayscale, which you are seeing on the leftmost, so let me take the pen. Yeah, on the leftmost, whatever you are seeing, this is a grayscale image. And if you see the grayscale image, there are some values which are 0. There are some values which are smaller. There are some values which are 254. What is the maximum value image can take? An image will have a value between 0 to 255. So this is one more basic fundamental thing that we should know. So for a grayscale image, which is on the left side, the value will range between 0 to 255, where 0 is black, 255 is white. And why it is called grayscale? Because the value will range between 0 to 255. If the value is more closer towards 0, then it will be darker. If the value is more towards 255, we will have the whiter shade. Therefore, it is a grayscale here. Then, this particular image, what you are seeing is a binary image. What is the difference between grayscale and binary? In binary, we just have only two colors, which is either 0 or 1, which is either black or white. We don't have anything in between. We don't have a gray colors here. So this is a binary image. So if it is a binary image, the value will be either 0 or 255. It is not between 0 and 255. It is either 0 or 255. Then why is that we have written 1 here then? Something dealing with the larger number, 255 is a bigger number. There are some pixel values which are smaller. There are some pixel values which are larger, which is 255. So in order to avoid unintentional bias, what we do, we normalize the data. I think most of you will agree, when we are dealing with machine learning, we always normalize as part of pre-processing. So here also we normalize the data and we divide each of the value with the 255. So when we divide 255 with the 255, the answer is 1. And when you divide 0 with the 255, the answer is 0. So that's the reason we are seeing the values are 0 and 1. 0 is denoted as black and 1 is denoted as white. And most important, when we are dealing with the real time data, we often come across a colored image. When we take a color image, each of the pixel value, if you see each of this pixel value, you will have a combination of three. What are those combination? We will have an R, G, and B. This is important because when we are dealing with the hands-on also, this particular concept is important. So coming to medical applications, most of the medical applications will be in a grayscale unless you explicitly look for an colored images. When we go for pathology images, we will have a pink stain. So therefore you will have an RGB component there. But otherwise, anything you take an ultrasound or a CT scan or an MRI or an chest X or an X-ray images, all these are the grayscale images. So the pixel values will be between 0 to 255. So next, most important, although it's a fundamental concept, number of channels, that is number of matrix. So when we deal with the color image is a combination of three channels. So what are those three channels? It is RGB, red, green, and blue. So channel here is a matrix. So we will take one matrix to represent, we will have one matrix to represent red. We will have a second matrix to represent green and a third matrix to represent blue. So therefore, the number of channels for a colored image will be 3, which means if you take one particular pixel value, one particular position, you will have totally three values here. We will just not have one, we will have 3. Therefore, and those 3 here is, first is R, G, and B. So number of channels for an RGB will be 3 channels. And second, when we deal with a grayscale, here often when I started my journey with CNN, I was thinking that for a grayscale also, since there are two colors, black and white, therefore the number of channels are 2. No, it is just only one channel, which is either black or white. So for black, when you add the white component, it becomes grayscale or it becomes white. So just imagine this as one single long line, and then you imagine there is a knob here. So as you move the knob, you will be seeing that there is a change in the intensity. So although for a grayscale, don't be in the impression that there are two colors. No, there is only one, which is, you can either consider it as a black or you can consider it as a white. So the number of channels here is once again only one. We don't have two channels, we have one channel. And for a binary images also, the number of channel here is 1. So a quick summary. So far what we have seen the 3 different types of images, grayscale, color image, and then binary image. For grayscale and binary, the number of channels will be 1 and the pixel values will be either 0 or 1 or between 0 to 255. When it comes to colored image, the number of channels here are 3 and the representation, any value that you take, any pixel value will be a combination of 3. So with this, we are now moving to a second segment. If this FDP is focusing more on deep learning algorithms, either yesterday or if not covered yesterday, somewhere you yourself will be very comfortable with artificial neural network, which is an ANN. So this is an architecture which you are seeing in the slide here. Now, why not use an ANN architecture or multi-layer perceptron for an images? Why not use the same for what was the necessary to go for CNN? Which means there should be some drawback with respect to multi-layer perceptron. For which applications we should use multi-layer perceptron? For which applications we should use CNN? So let's understand that. Now, what is an input? Here we are dealing with images. Here images will be, there will be a dimension for an image which will have an height, width and a number of channels. So here when you see number of channels as 3, when you look here, we have 3, which means we are dealing with colored image. And here the dimension of the image is 28, 28, which means the height is 28, width is 28. Number of rows are 28, columns are 28. Okay. Now, the topic here is why not use multi-layer perceptron? Now, when you multiply this 28 to 28 into 3, we get the value 2352. So it's a simple math. So now 2352 number of neurons, or this is the size of the input that you are passing to a multi-layer perceptron. Because for a multi-layer perceptron, you will be having a data in the CSV file. We'll have a tabulated data where every of the column here are the features, right? How many ever features are there? So many are the input values that you will be passing to a fully connected one. But here in an image, every pixel is a feature, right? So here the input that we are passing is 2352. Now, this is a very, very small dimensional image that we are passing. The resolution of this image is very, very poor. We cannot even identify any features in this particular one. So if you go to little more clarity image, when we increase the dimension, now say for example, you have 200, then look for number of neurons that you're going to pass, or what will be the input size here. It is 1,20,000. So can you imagine having so many number of input feature values being passed? You can say why not? So if that is the case, if you are passing 1,20,000 values here, think of how many number of weights and biases, and if you have many such hidden layers, can you imagine the complexity of the architecture? Right? So because of this, this is one primary reason why, for images, we will not be going for multi-layer perceptron, because computationally it is expensive. So the same with a little more clarity, I have taken one example. Let us see, there is one image here too. That too is, we know that image is read as a matrix. So whatever you are seeing, it is a matrix representation of 2. Now, the very first step, if you want to pass it to a fully connected neural network or multi-layer perceptron, it cannot be in a matrix form. It has to be passed as a single vector. Now, when you convert something in the matrix form to a single vector, what is getting lost here? Can you just answer to yourself? This is something in the matrix form, which is in two-dimensional one. From two-dimensional, when you're converting it into a single vector, is it not, you are losing its positions, and you are losing its structure also? What does it mean? Now look at this. First, initially, the entire first 7 values are the first row values. Second, you have 0, 87, 240. Then we have 0, 87, 240, and so on and so forth. So something which is in 2 cross 2, something which is in a matrix form is converted into a single vector. When you convert into a single vector, what exactly has happened? You see here, this 0 and 240 are the neighbors. This 0 and 87 are the neighbors. And similar way, 87 and 13 are the neighbors. But when you convert that into a single vector, are the neighbors still? Answer is no, right? So with this, what exactly we have lost? We have lost the spatial relationship. What do you mean by spatial relationship? Whenever we flatten the image into an one-dimensional one, the pixels are losing its position. And this, we say that the spatial relationship is being destroyed. And the local dependencies are lost. What do you mean by local dependencies? Now, when you see here, there is a curve, right? And here, if you see, there is one straight line kind of a structure. But when you convert that into a single vector, it is no more curve. It is no more curve any, right? You're losing it into, so all these local dependencies are lost. That is the primary reason why, multi-layer perceptron cannot be used for an images. So in case if that example is not, if you have not understood this spatial relationship, there's one small example here. You can see there is a numbers from 1 to 9. Now, first step, you have to convert that into, a single vector. When you convert that into a single vector, you are seeing something like this. Now, what exactly is the problem? You see here 1, 2, 3, 4, 5, 6, 7, 8, 9, there is a relationship. So when you see 1, 2, 3, they are horizontal neighbors. 4, 5, 6 horizontal. Vertical are 1, 4, 7, 2, 5, 8, 3, 6, 9. These are vertical neighbors. So there is a relation. But when you convert that into a single vector, can you see here 3 and 4 has become a neighbors. In a single vector, 3 and 4 are neighbors. But in the image, 3 is independent and 4 is different. And when you see 2 and 5 are the neighbors in a matrix form, but in a single vector, 2 and 5, they are not neighbors. This is called, destroying the spatial relationship. This is something which is not acceptable. And the next, look at the parameter exploration. So since here it is 7 cross 7, we have got one vector, one neuron connecting to all other neurons. If you imagine there are 49 neurons in the hidden layer, one neuron connecting to 49, second neuron connecting to 49. Similar way, 49 inputs are connected to 49 neurons at a hidden layer. So how many number of weights and biases we get? 2401. So this is a simple 7 cross 7. But in a real world application, we will never have such a low dimensional one. So parameter exploration, which often leads to slow training and then increases the overfitting risk. Most important concept, I want you to make a note of this. This is called a data augmentation. The next important before we start with the CNN. Now, why is that the data augmentation is very important when we are dealing with images? Whether it's a medical images, though it is very, very important. I'll come to that point. Now, for our human intelligence, our human eye is trained so very well that when you see this image, you say it is X. This is also X. This is X. And this is maybe some cursive handwritten X. So for human eye, all these are different orientations of X. Similar way, when you call this as O, then all these are different O's. But for a human, for a machine, all these are different. Why they are different? Machine just deals with numbers, nothing more. So when you see, let's take all these three images. There is nothing here, there is a nothing here, and there is something. So which means they are not same. At least this image is totally different from the first two. Now let's take the second one. I mean second row, first pixel. Take this, there is no value, but there is some value. And here there is no value. So definitely system will tell that they are not the same. Why they are not same? Because the values, positions, the values are not the same there. But that's not correct, right? Now, you can ask how it is related to a medical application. Now, you have, although it is a little humorous here, but this is very important point. Now, when we go to an hospital, when doctor asks us to lay down for an scan, that point of time, if at all, if our pain is a bearable pain, we will be able to lay down comfortably. But if the pain is too much, we may not be able to sustain or lie down for a longer period of time. So in that case, we'll be moving. We may not. We will be little slant, or our position will not be proper. In that case, in that position also, the scan machine is going to capture the image, and the human eye can able the doctor's eyes can able to tell that okay, the patient has a slightly moved, but still we can able to identify that there is a lesion of there is a problem. But for a machine, we cannot tell in that way, right? We cannot tell the machine that the person was not feeling well, so he was not lying properly, or the patient was not lying properly. No. So, whatever the orientation of image which is coming, the model should be able to handle it. Now, just because any orientation the model should be able to handle, we cannot ask the patient to go upside down for a scan because we want the model to be trained on a different orientation. We cannot do any of these, right? So we require some technique where you can artificially augment these images by and what is the ultimate aim? By doing this, we are increasing the sample size. Now, let us understand. Data augmentation is one of the most important concept. You deal with any application, you require this concept. Now, what exactly is data augmentation here? You are artificially increasing the size. And how is that you are artificially increasing? Now, whatever is the original image that you are slightly creating some different orientations of that particular one. By creating some modification to the existing images, you are increasing the sample or you are increasing the data size. With this, what is the main advantage? You can reduce the overfitting and you can able to give a better generalization. Now, if that is the case, how are we going to increase? The very first concept or the very first is scale down the values. How is that we scale down? If you consider an image of a 5 cross 5 here, we have a matrix of a 5 cross 5 where the values are between 0 and 255. Now, the first step is divide each of these pixels with the 255. So you can divide 205 with the 255, you will get 0.803. 101 with the 255, you get this value, and so on and so forth. You can ask, why is that you have written 1 point instead of writing just 1 divided by 255? This is just for Python convenient sake. We have written 1 point. Python version 2 it explicitly requires floating a division, but otherwise from Python 3 onwards, even this point is not required. So let's not deviate. So first step is divide each of these pixel values with the 255 so that you are scaling down the values between 0 and 1. Okay, now let us understand what are different augmentation techniques. So, deep learning frameworks, we have Keras, TensorFlow. And in TensorFlow, we have an image data generator, which is an powerful package. And that package will take care of this data augmentation. But when we are learning, we have to understand, rather than just taking the package, we should understand what is happening behind as well. So, what are different pre-processing or data augmentation techniques we have? The first one is scaling down to 255. Divide it with the 255 so that you can scale down between 0 and 1. Next, we have shear range. What exactly is the shear range? This is what is the shear range. Slanting. Now, this is the original image, and the slant, how much degrees you want to bend. So just because you want this, you cannot ask the patient to bend and then you capture the scan, right? You perform the scan. That is not possible. So even if, because of extensive pain, even if a person has slightly bent also, still the model should be able to. So then how is that you are able to capture such kind? How is that you are taking care of that kind? Is, by fixing this shear range. The shear range is a number. It is a number which you are going to fix here. And the back end, what is the math that is going to happen? Whatever the number that you are fixing here, that number gets multiplied with 180 divided by pi. So this is the math. So whatever is the value that you are going to get, that is the degree with which it is going to slant it. So you can able to see this is the original image, and because the shear range you have fixed as 0.2, you can able to see that there is a slight slant in the image. So this is important step. And second, we have a zoom range. What is a zoom range? How closely you can able to, sometimes when things are not very clear, what is that we do? We zoom it and then see. And what is the purpose? So that we can able to visualize the lesion of interest in from a different orientation, from a different scale. So what is this? Whatever the value that you give, the math behind is 1 minus that value. 1 minus 0.3 is 0.7 and 1 plus 0.3. So the value will be 0.7 to 1.3. So the value will be between this, and the system is going to fix one value, and then accordingly it is going to have an zoom. So next, this is how you can able to view a different zoom range when you fix this. Then we have horizontal flip and vertical flip. This is the original image, horizontal flip and vertical flip. Then the most important, we have something called as width shift range and height shift range. Now, what is width shift range? This is once again very, very important when we are dealing with ultrasound images. We often come across this particular problem. So what exactly is width shift range? Width is dealing with x-axis, right? So horizontal one. So shift is you are shifting. Horizontally, you are shifting. So horizontally, if you have to shift, you can either shift left or right. So width shift range is moving the image either left or right. So how does it performs? You'll be fixing some value. The value here is 0.2. And what math will happen behind that gets multiplied with the number of pixels on the x-axis. So if there are 200 pixels, which means if the width is 200, dimension is 200, then 0.2 into 200 is 40 pixels. So 40 pixels you will move either left or you will move towards the right side. So if it is minus 40, it means you are moving towards left. If it is a plus 40, it is moving towards the right side. So how does it looks? This is what is shifting right. So when you shift right, is it not the left side portion is dragged here? So when left side portion is dragged, you will have those values as empty. Can you imagine there is an image and then you are moving the image towards right side. When you move an image towards right side, the left side portion is empty. Now, if the left side portion is empty, how is that you're going to fill those empty places? That is where this is right shift. I mean, this is left shift. This is a left and this is a right shift. Yeah. So when you move towards the left side, then the right side portion is empty. Then how is that we are going to fill these values? Then we have something called as fill underscore mode. In Keras, we have fill underscore mode, and those fill underscore mode can take the value. For example, imagine this is an image, because whatever the image that you are seeing will be represented in the pixel form, which is in the matrix. Let us assume this is the image that we have. Now, fill underscore mode, why do we require this? Because you are shifting the image either left or right. When we shift the image, then if you are shifting towards the left side, then right is empty. If you are shifting right, left is empty. So how are we going to fill those positions? We will fill those positions by using any one of this. Nearest is, now see, let us assume this image A, I am shifting right. So when I'm shifting right, can you imagine that this portion will go out? Then this entire will come here. This will come here. This will come here. And this will come here. Then this position is totally free. This place, it is totally free. When it is free, what are we going to fill that? Nearest is when you will get this. What is the nearest? Whatever is the nearest value, that value is going to be filled in this empty. That is the reason you can able to see there is a green, whatever was the last value here. The same value is being copied throughout. That is the reason it looks like it is being dragged, because it is the same green, same black, which is placed throughout. This is called the nearest. Constant is, instead of filling the nearest, you're going to place 0. Then in that case, you will have all these values. You'll have all this as a black, 0. Black color you will have. Then we have a wrap. What is the wrap? What has come out that you are going to place in that empty. So this is the wrap. What had come out? This 5, 10, 15, 20, 25, this had come out. So you're going to place that in the empty position. And the last is the reflect. What is the reflect? Now, when, let me erase to show you the reflect one. So what is empty? Empty is, this position is empty. Now, and you, this one is here, and this two is here. So from empty, from that, when you are seeing, when you stand in this particular place, when you see, what values you will observe? Is it not you will observe this values? Mirror reflection. So it is 2, 7, 12, 17, 22 is what is being placed. So what is a reflect? When you stand in a place, what you're going to see, that is placed as the, so whenever you're dealing with the medical applications, we should never use a reflect. This one point we have to take care. Now, you can ask the question why we should not use the reflect. Is it not you are unnecessarily introducing one new feature by placing these values there? So this is the reason why reflect should not be placed for a medical application. But yes, nearest constant is something that we can go for. Yeah. So, and next, this is width shift. Can you able to see? Different orientation. Similar way, height shift is the same concept, but you are moving the image up or down. So this is a right shift. Height shift, and we have a rotation. Rotation is changing the image from in a different orientations. So whenever you are going for this, you will always use a parameter called fill underscore mode. So here it can be either nearest or it can be constant. So, and next, how do we store the data? This is important. Whenever we are, more specifically, when we are working on real-time data, so real-time data here is the data which is not openly available in the internet source. You have collaborated with some hospital and then you have collected the data. I'm naming this as real-time because often people get confused. Real time is not a live data. The data which is taken from the raw data taken from the hospital. So when you are working with real time data, when you were dealing with ANN, you had a data in the form of a CSV file, or you will have a data in the form of an Excel file. And when you are doing an implementation, it is, read underscore CSV or read underscore Excel. So from pandas, you were calling read underscore Excel or read underscore CSV. There you are passing your data set. So, and you are performing the operation. But since we are dealing with an images, what care has to be taken care? How is that you have to store the images? Suppose if somebody is working on binary images, binary classification problem, then and you will have training data, testing data. If you feel you want train data, test data, and validation data, then create 3 different folders. Create a master folder. Let the master folder name be whatever is the disease on which you are working. Suppose if somebody is working on COVID data, so let the main folder name be COVID underscore COVID. Under that, create three subfolders. Right click, create a folder. Right click, create a folder. So create three folders. In that folder, first folder name will be train. Second folder name will be testing. Now, if you require validation also, create a third folder and write name it as validation. Valid. Then, under each train, under each folder, when you double click on that folder, create again a subfolders. Now, what are those subfolders? So, under train, again you will have a subfolders. These subfolders are actually your problem statement. Suppose if your problem statement is classifying benign malignancy or border case, somebody is working on tumors where you want to classify it as benign, cancerous, non-cancerous, or border case. Then under train, you will have the folders. How many subfolders? The subfolders will define your problem statement. If there are two subfolders, it means it's a binary classification. If there are three subfolders, it is a three-class problem, multi-class classification problem. And this, suppose if it is an COVID or non-COVID, then that folder name should be the COVID, and second is non-COVID. I hope you are understanding what I'm explaining to you. So the folder name should be your the class names. Why it is important? Because when you are dealing with CSV file or an Excel file, for every of the sample, for every row, towards the end, you used to have a label. But here, what is the label? We will get an images in one pen drive or in some disk or some hard drive, drive link. So how is that we are going to name each of these? So this is how we are going to label. So we will put all the images and if it falls under COVID images or the X-ray, just X-ray which has infected with the COVID, all those images will be in this particular folder, and the normal images are in this particular folder. I hope it is clear to you. If at all, if somebody is dealing with one more class, then create one more folder. Create one more folder, and here you will have maybe border case, and in that you will have images. I think somebody would have raised a question here. I'm not able to see it. I'll be taking up all your questions towards the end of the session. Yeah. Now, the next important, what is that we have written all of this? Why it is important here is, especially you look at target size. Here we have written width and height. Now, when you are collecting the data, each of the image will be of different size. So can we manually sit and crop the images to a same dimension? Can we manually do it? Will it not be too time consuming one? Or if you say that I have so many students, I'll give it to the students and I'll ask them to do. The minute you give it to the students, then they are playing with the data. So the whole purpose of the confidentiality or ethical clearance used for research purpose, everything is lost. So instead, what you do, whatever may be the size of the data that you have taken, the size, I'm not talking about number of images, I'm talking about the size, which is each image. If I'm taking every image as 256, 256, one image is of size 143, 256. It is of different sizes. If at all, if you have, bring down everything to a common range, you can define a width and height here. So that's the meaning of width and height. Whatever you specify here, all the images by default will be retained, will be read to that particular, the size. Then class underscore mode can either take binary or categorical. If you are dealing with the binary data, the binary classification right here as binary. If you are dealing with multi-class classification problem, right here as categorical. Rest all, I think we can skip. This is all the explanation. Yeah. Okay. So with this, we are slowly moving towards, let me see the time. Okay, slowly moving towards CNN. Now, when we were dealing with ANN, multi-layer perceptron. Biological neural system was the inspiration behind building a multi-layer perceptron. Biological, I think if a teacher is teaching deep learning, the very first class, we always often go back with the same biological diagram, and then we say that from here the concept has come up. So if that is the inspiration for developing an multi-layer perceptron or artificial neural network, what is an inspiration for building an CNN? So it is an human inspired only, right? So which part of the human is inspiration for developing a CNN? It is an human eye. So how human eye works, similar way they tried mimicking and came up with an algorithm called CNN. If it is a human eye, of course, it is connected back to an brain. So from human eye to brain, how exactly the functionality takes place. So from human eye, you are going to visualize the image. It first goes into V1. V1 is responsible for whenever we look for any images without our knowledge, the very first thing that we see is we look into its edges, corners, lines. We look into the basic low level of features. So V1 is responsible for detecting the low level of features. So when we take a face, it is the contour of eyes, mouth, the face outlines. Then from there, we move to V2. V2 is actually responsible for, it takes the V1, whatever you have extracted, it combines and it starts forming the shapes. V2 is responsible for forming the shapes. So then V4 is responsible for all this V1, V2, V4, all these are visual cortex, visual areas. So V1 is primary visual, V2, V4 are secondary and tertiary. These are responsible for detecting the shapes and then the color. And the final one, that is IT, inferotemporal cortex, is responsible for identifying, recognizing a particular. So this is how our human eye and brain works. So similar way, when it comes to CNN, so CNN, we will be seeing very shortly. You have many number of layers. So V1 early convolutional layer is responsible for V1 operation. Then intermediate convolutional layers are responsible for V2. Deeper convolutional layers are responsible for V4 operation. And in CNN, we have a fully connected layers. That is after flattened layer is responsible for IT work. So this is the replica of biological. CNNs are replica of biological hierarchy, where it moves from V1 to IT. V1 is responsible for low level and IT is responsible for high level features. So with this, we will start with CNN. It's one of the most powerful algorithm. The revolution of CNN deep learning has started after introducing the CNN concept. So the primary applications of CNN, when do we use CNN? Whenever we are dealing with the images, we go with the CNN. So CNN deals with the images. Okay. Now, with the images, what all applications we have? One is an classification. Second, we can segment. And the third is you can go for a detection. So for all these applications, we require CNN architecture. You have a set of images and you want to classify them as, you want to classify into one of the category, image classification. We use CNN algorithm. Then, in the entire image, you want to, in order to identify me as Ashwini, you don't require my entire photo. You require some portion of my face is sufficient to say it is so and so person. So, which means segmentation, you need to segment only that particular. Rather than going for a conventional, image processing algorithms, we can go with the deeper, deep learning segmentation algorithms, which is UNet, which is once again CNN based. Then, in the entire image, you have an, your class image, you have all the class teachers, management, and you have all the students. In that, you want to identify the class CR. You want to identify the principal. You want to identify your best colleague. So, you are going to identify among the multiple objects which are present, you are identifying a particular object. So, which is once again a CNN based. So, CNN is a very powerful algorithm which is responsible for image classification, object detection, and image segmentation. So, even in medical applications, we will be using CNN based. Now, in object detection, yeah, when an image is passed, you want to draw the boundary where exactly the lesion is present, or you want to segment only a particular lesion where the tumor is present. So, even in the medical applications, all these CNN is extensively used. So this is how the early layer looks, where you have lines, and when you go into deeper layers, you will be able to identify a particular object. Yeah, the output looks something like this. So these are the different components of CNN. So you have an input. You will be having a convolutional layer, then you have an activation function. We have a pooling layer, flattened layer, that is fully connected layer, and then we have an output layer. Then the extended components are, you can have a normalization layer and you can have a dropout. So let's look into the first four here: convolutional layer, activation, pooling, and fully connected. For this today's discussion, we'll be looking into these four. Now, I would like to ask a question to you. When I ask, what exactly is this image? What is that you will be answering? You will say that maybe, ma'am, I think it is elephant. Now, definitely, we all will agree that it is an elephant. If it is an elephant, now when I ask the next question to you, what did you looked into to say that it is an elephant? One will answer that, first I looked into this part, it's a trunk. Then to some extent, I understood that it may be an elephant. Then I cross-verified by looking into this portion and then the body. This is how we have identified, right? It is just not by looking at once we were able to. Yes, something it looked like, but we have combined all different features and then we said that it is an elephant. Similar way, right side, it is an kangaroo. So the next, it is an chameleon here, and here it is an owl. So why I have told you this is, now when an image is given, your eye, human eye, has gone through the entire image. You extracted something, and then you are able to say that it is so and so. Correct? This is how our human eye works. If that is the case, you require one human eye even to a machine also. When I say machine, it is a model here, algorithm. You require one eye to an algorithm also. And what is the requirement of that eye? That eye should go through the entire image and it has to extract the features, right? That eye here is a kernel. So it plays a major role, kernel, which is responsible for going through the entire image. How it will go through, I'll tell you. It will go through the entire image and it will extract the features. Now, when it is going through, what are the two mathematical operations it will do? The two mathematical operations it performs is element-wise multiplication and summation. This whole concept, we call it as convolution. So convolution is a mathematical operation where you are performing element-wise multiplication and you are performing a summation. Now, let us see what it is. Do you agree that it is an image? 6 cross 6 is one image. And you know very well that the image will be represented as a collection of pixel values. So here it is a matrix which is having a values here. We require one eye, human eye. So that eye we call it as a kernel. And that kernel size should be always an odd size kernel. So it is 1 cross 1, 3 cross 3, 5 cross 5, 7 cross 7, 11 cross 11, 9 cross 9, 11 cross 11. Usually we fix the odd size. So it's a first homework to you. Why we have to go for odd size kernel? I give this as a homework. I think I'm coming back again on 10th. That day I'll be asking you this question, why we require an odd size kernel only. Okay. Yeah. So now what operation is going to happen? Now, from where did we get these values? These are fixed values. What do you mean by fixed? Input is something which has come to us. Now, whatever is the input, that input is converted into, not converted, is read as a collection of pixel values. So which means these are the values which are fixed. Now, whatever is this 3 cross 3 that we have taken, initially we have taken some random values. Over a period of time during back propagation, we are going to update these values. So which means initially, whatever the values that we have here, these values are some random values. Now, what is the convolution operation? So first, since it is 3 cross 3, since we are doing matrix operation, definitely the size has to match, which means if you have taken 3 cross 3 of kernel, here your image is 6 cross 6. In that, you have to fix only 3 cross 3 part. So now you are taking only this 3 cross 3 part of the image. You have kernel, you have 3 cross 3 part of an image. Now perform element-wise multiplication. What is element-wise multiplication? Is it not 3 is element? 3 is getting multiplied with this 1. Then 1 is getting multiplied with this 1. 2 is getting multiplied with this 2, and similar way the second row, second column is getting multiplied with this second column, and the third column elements are getting multiplied with this third column. Element wise multiplication. So first operation is element wise multiplication and addition. So we get minus 5. That minus 5, that is the resultant value. Now, the next operation what we do is we are going to stride, because how our human eye will go through the entire image. So which means this kernel also should go through the entire image, which means now you will stride it. So, how do you stride? You will just move one towards the right side. Can you see? This is the initial one. When you stride, you got this portion. I hope you have understood this. Now, when you stride, the kernel is now looking into this part of the image. This part of the image. Right? Now, again, you perform same element-wise multiplication, addition, then you get this value. Again, you stride it. Again, element-wise multiplication and summation. Again, we stride element-wise multiplication and addition. Have we completed looking into the entire image? Answer is no, right? Why? Because we did not see this portion, the bottom portion we did not see. So here, when a human eye is going through, here also it will go through every part very clearly. So when it goes next, you see where the highlight portion. So you have completed the entire first. Now you stride, you come down one step and you move left. So you take now this portion of the image, you will do element-wise multiplication, the summation, you get this result, and so on, so forth. You will complete this. When you come to the last portion, you get this result. Now, what is that we have obtained? What are all these values? This is the feature extraction. So what you did is a convolutional layer. In convolutional layer, what operation is taking place? Convolution operation is taking place. And what is the convolution operation? Element-wise multiplication and addition. Element-wise multiplication and summation. By doing this, what are we doing? We have extracted the features. Now, what the features it has extracted? Now, whatever is this 4 cross 4 we got, we have extracted the features. Now, from this, you can ask the question, the input image size is 6 cross 6. But the resultant what we got is 4 cross 4. Have we not lost the information? We have lost the information, right? Now, which information did we lose? So, once again, most important, you go back and then observe. I'm sorry. Yeah. So look at this. Initially, you had seen 301,158,272. Now, when you moved right, after you performed this, when you moved right, you look at this, which portion of the image you are seeing. You are now seeing this portion of the image. Now, again, you are moving right. You are seeing this portion. You are again moving right. You are seeing this portion. Now, observe very carefully. Now, when you come down, you are seeing this portion, which means this number 3, what was there here, you had seen this image, this portion of the image only once. When did we see this? Can you go back? Look at this 3. Rest all you are seeing at least one more time. This 057,182, you are again covering that. This 1 and 2, this 1 and 2 is again being covered when you come next. See, again you are seeing this 1 and 2. But when you come to that the 3 is something you had seen only once. Similar way, I'm not only talking about this 3, it can be even this 4, it can be this 2, it can be this 9. So all the border information is lost. So from this 6 cross 6, you got this 4 cross 4 because the border information is not being taken care. That border information will be, even if you doesn't want that border information also to be lost, then we have a concept called padding, which we will see. Yeah. So image, when you apply a kernel, you get this output. This image, when you apply a different kernel, you get this output. This is a visualization, how it looks. Okay, there is a small math behind. All what you know is, you know the input size, which is 6 cross 6. You have fixed the kernel size, which is 3 cross 3. If for this input, for this kernel, what will be the output? What will be the output of convolution layer? The math behind here is n minus f plus 1. So what is n here? 6 cross 6. And f here is a filter, which is 3 cross 3. So what is the formula? N minus f plus 1. So substitute the values in this. You will be able to get this value 4 cross 4. So there is a feature map, the output, whatever we have got, this 4 cross 4, technically we call it as a feature map. There is a shrink in this feature map. This problem can be solved by using the padding. So what is padding? During convolution, the size of the output feature map is determined by what? By the input, by the kernel, and when kernel is applied onto this input, we get the feature map. So, which is smaller in size than the input. So, the information is lost. Which information is lost? The information at the borders have been lost. So, we use padding. How we use padding? This is how we use padding. Now, just imagine before we had a 3 here. I'll just talk only with respect to 3. So when you apply kernel, when you apply this 3 cross 3 kernel, you go for this. This is 3 cross 3. You're seeing 3 once. Then again, you are going for this. You are seeing a 3 second time. Then you go here, so on so forth. Then you come down. You come down, you take this 3 cross 3, you are seeing 3 again. Then you are going for this 3 cross 3, you are seeing a 3 again. So definitely, have you not taken care of border information? So this is called a padding. So where 0 is being appended to all the 4 sides of an image. So initially it was a 6 cross 6. After you applied padding, now let us see, ideally our output should be again 6 cross 6 because the information should not be lost, right? The output should be 6 cross 6. Let us see how that output is 6 cross 6. Now you see, After you apply the padding, the output is 6 cross 6. That means, what is the formula then? What was the formula behind? It is n plus 2p minus f plus 1. The formula remained the same, n minus f plus 1, n minus f plus 1. But because the padding is being introduced, it is a 2p term has been introduced here. So just substitute the values, you will be able to get. So n value here is a 6 plus padding is done. Yes. So answer 2 p value is 1. So 2 into minus 3, f is 3 and plus 1. So if you do this calculation, you will be able to see that the resultant is a 6 cross 6. Yeah. So when no padding is done, it is n minus f plus 1. When there is a padding, it is n minus f plus 1 plus 2p. Right? Now, you can ask the question, is it compulsory that we should apply only one layer of padding? If that is the question of the participants, the answer is no. You can even apply two layers of padding, two layers of zero padding. Then how do you write the code? If it is just one line, you write padding equal to valid, then there is no padding that is applied. When padding equal to same, then it means you have applied one layer of zeros. Then if you want two layers, you want instead of just only one, I want one more border. Then explicitly you need to specify. We need to specify zero padding, 2 cross 2, which means two rows bottom, two rows top, left, right, bottom, top. You will have two layers that is being added. The next question, what you can ask, what you may be having here is, apart from 0, can I add some other number? That can be the answer. Just think, apart from 0, can you, if you add some other value, is it not you are confusing the model by saying that that is something, some pixel value there? So every pixel contributes a feature, right? So a pixel value, which means there is some feature present. So by you, instead of adding 0, if you add some number, is it not? It's not correct. So that's the reason we always go for 0 padding only. Stride concept we have discussed. So stride is, you can either stride one or you can stride more than. If stride is one, then denominator divided by s. If s value is 1, it is just the previous formula, right? But if a stride is more than 1, then what will be the formula? Then definitely denominator will not be 1 anymore. Denominator will have whatever is here. Since stride s is equal to 2, we will have denominator value as 2. So you multiply and then perform this, you will get some value. Now you can ask the question, the minute you say divided by, there can be high possibility that you may get the floating point. You may have a decimal value. Can we have a feature map as 5.5, 5.5 into 5.5, 5.25? We cannot have anything in terms of decimal, right? So therefore, the formula is a floor. So what is a floor here? How do the mathematically floor? Any decimal value, it converts to next highest integer. So 3.5, 3.1, 3.9. What is the one? I'm sorry, floor, right? So it will convert it into the nearest integer. So 3.5, 3.1, 3.9 is 3. So that is floor. Seal would have been the opposite, which will go to the highest. Um, yeah, so this is what is the stride concept, and how do you implement the stride? If the stride is only one, then you need not have to write. By default, when we are implementing, we can just write only so much. But if the stride is more than one, then explicitly we need to specify by writing stride equal to 2, 2. Now, often when we teach this, immediate question what we get from our from the students' side is, we get one question. Ma'am, what is it compulsory that we always write stride as squared number or n cross n only? Can I write a stride as something like this? Can I write a stride as 2 comma 3 or 2 comma 4 or 3 comma 5? Can we write a stride in this way? Answer is yes, definitely we can, but the care has to be taken care. If at all, if your image is a perfect square, then the stride has to be n cross n only. But if the image is of rectangle in shape, often our the real time images will be in rectangular shape. In rectangular shape, you cannot convert that into square because you may lose out a lot of information. When there is a rectangular shape, it has to be an the aspect ratio. When the aspect ratio is not the same, which is 128 cross 256, then the stride value also should be of this. When we write 2 comma 3, it means 2 towards right and 3 towards down. So with this, this is once again same convolution. When we are dealing with the colored image, how does it works? All now, up till now, what we have seen is with respect to binary or grayscale. But what when we have an colored image? When we have a colored image, number of channels are 3, right? So when we have the 3 channels, it means you have 3 such matrix to perform. Then you cannot just use only one kernel. When I say one kernel, I'm not talking about, see, you cannot have a kernel which is having only one channel. Here, a kernel also should have the same channels as that of the input. So in that case, how the operation takes place. So how do we perform the operation? So see here, once again, it is n minus f plus 1. You will get 4 cross 4. Let us see this. You have RGB component. We have 3 such channeled kernel. You will multiply, you will once again perform a convolution operation individually. You will get 3 such values. You will do an addition of all those and the resultant is 1. I hope you have understood this. Similar way, you will stride and perform the next convolution. You get this value. You get these, you get this. You will do an element-wise addition here and you get these values. So, when you are dealing with an RGB, you will have an image with 3 channels. When you take a kernel also should match with the channel. Then when you perform an multiplication, don't think, you will get multiple values. Yes, even if you get multiple, ultimately you will add and make it as one single value here. So this is what is the detailed explanation. Yeah. So you will multiply, you will get this value, you will stride, you will multiply, get this value, you will stride, and so on, so forth. Here you can have multiple such kernels. So when we have multiple such kernels, then you will get multiple such feature maps. So with one image, one kernel, you got one feature map. If you take one more kernel and with the different values, when you multiply, when you perform a convolution operation, you get one more feature map. So on and so forth. Right? So what will be the output size? How did we get the 4 cross 4 into 2? What is the math behind? This is the mathematical formula. N minus f plus 1 into n minus f plus 1 into nf. Nf is number of such filters. How many such filters are there? 2 such filters are there. Therefore, this is 2. And how did we get this 4 cross 4? It is simple n minus f plus 1. Next, this is all about, in short, what is convolution operation doing? It is extracting the features. And how it is extracting the features? By performing the convolution operation. And what is convolution operation? Element-wise multiplication and summation. Next is ReLU. What is ReLU? It is an activation function. which is max of 0 comma x. So you will pass each of these values, max of 0 comma 1, max of 0 comma 14, max of 0 comma minus 9, max of 0 comma 4. So just substitute the value. Wherever there is a negative, you are making it as 0, because max of 0 comma minus 9, what is maximum between 0 and minus 9? It is 0, right? Because negative values are smaller. So you will get 0 value. Max of 0 comma 14, what is the maximum among 0 and 14? It is 14. So this is a ReLU. So let us assume this is the output of the convolution operation. How did we get this? We have performed element-wise multiplication and addition. We got this feature map. That feature map is now passed to ReLU. We are going to get the values. So we have got these values. I think this point is clear to you. Now, let us assume, see here, very important. I want you to focus here. When we take this ReLU, when we see, when we take this input, let us assume the input here is X. For this input image, we have taken some kernel. This kernel, when we are performing an element-wise multiplication, stride, all that, we have got this convolution operation. This is the feature map, output of convolution layer. Yeah. This is the output of the convolution. Yeah, we have got this. Now, what features it has extracted? Look at this image very carefully. Now, what is this image? Image is all about this X. This is image, right? Now, in order to identify it is X, you need to extract this feature. You need to extract this feature. You need to combine. You need to do some operation like this, correct? Now, when you look into this, you have taken this kernel, some kernel we have taken. After we have performed this operation, look at this slide look at this very carefully. What feature it has extracted? Look at this portion. Is it not? The values here are very high. In case if this is not clear, now you observe, after we have passed it to ReLU, we have got this as an output. All negative values have been replaced. So when you have got this value, when you observe it very carefully, is it not the diagonal? Look at this primary diagonal. Is it not all the values here are very high? Which means, is it not the in convolution layer under ReLU, is it not the model has extracted this portion of X? Do you agree to this? Similar way, you have an input image, you have used an other kernel. Now, you can ask, ma'am, why not we do once again the same operation? I will pass this kernel only again onto this input image, so that maybe this time the model may extract different features. Answer is no, right? We cannot pass the same kernel. Why we cannot pass the same kernel? Now, just because now you want some more features to be extracted, when you pass the same kernel onto this input image, mathematically the operation is element-wise multiplication and summation. How many ever times you pass through, is it not the values will remain the same? So you cannot extract, just because you want more features to be extracted, you cannot pass the same kernel again and again. What is the only answer? Use a different kernel. So now let us assume you have used this kernel. When you have used this kernel, you get some other features, although that calculation is not being shown here, but you get a different matrix here. That when you pass it to ReLU, you get a different value here. So let me erase and then show you something here. You see, this is one image, input image. For this, you have applied a kernel. And then you have passed it to ReLU. You have got some features that it has extracted. Now just observe only this portion. Now I'm going to change the kernel. So when you have changed the kernel, look at it has extracted some other features. So combine the previous it has extracted the horizontal lines, and now it has extracted the vertical. So together, can I say that by combining, it is an handwritten 4? So different kernels we have to use for extracting the features. So how do we, write in hands-on? How is that you will be writing? You will be writing activation equal to ReLU. Now look at this convolution 2D. 3 cross 3, which means you have used a 3 cross 3 kernel. Input shape here is a 64, 64, 1. So here, although it is some 7 cross 7, but 64, 64. What is this 32? 32 here is 32 such kernels we have used. Here we have used 2 kernels. 32 such kernels we have to use. When we use 32 such kernels, how many feature maps we get? 32 such feature maps we get. So I hope you are understanding. This I think we can skip for the yeah. So, how do you calculate the total number of parameters? The total number of parameters, the formula here is, WH, FW, that is kernel width and height, number of channels plus 1 into number of such filters. This is the formula. We can just Google it. We'll get the formulas. Take the dimensions and then apply. We are going to get the values. Suppose if our input is 32 cross 32 into 3, that is 3 such channels, and our filter is 5 cross 5, and we have used 6 such filters, then the total number of learnable parameters are 456 are the learnable parameters here. So calculating the output size, the formula here is I minus F plus 2P divided by stride plus 1 into D. So once again, these are all the standard formulas. What is I? Input. F is the filter, whether you have applied padding, yes or no, stride, and D is the number of channel filters, how many filters we have used. Suppose if this is your configuration, input image size is 32, 32, 3, filter size is 5 cross 5, number of such filters are 6, stride is 1, there is no padding that is applied. Just substitute the values into this formula and you see the output, the size what you get is 28, 28, 6. Similar way, with the padding, we get this size. This is important concept. Why? I'll tell you shortly. And the next layer, what we have is a pooling. Now, you can ask the question, ultimately, one of the primary reason why we did not go for multi-layer perceptron is image is 7 cross 7 or 28 cross 28 or 200 cross 200. If at all, if the channel is a 3, number of neurons or number of input features are 1,20,000. So it's a huge size, parameter exploration. So how do you overcome this problem? How do you avoid this? Not avoiding. Our ultimate aim is multi-layer, fully connected neural network is very nice algorithm to implement. But the problem is the size what we are giving is a very large one. How do we avoid? Convolution is responsible for feature extraction. ReLU is responsible for converting zeros, negatives to 0. But nowhere we have reduced the size. So now we need to now shrink, start reducing the size. How will we reduce? Pooling. What does the pooling does? It will take the input. It will take one window size. Now, in order to say it is X, now the X, it has taken this feature, right? It has extracted this feature. Now, in order to say it is X, you don't require so much of, even this much line also will help me to identify it is X, right? So you don't require all the features in order to say it is so and so. Most important features are sufficient for you to say it is a particular So what pooling does, it starts shrinking. How is that it shrinks? Now, whatever is the size that you have fixed, 2 cross 2, among this, extract most important one. Then stride it. Then, the next, among the next among this, anyhow, it's here. Okay, so in types of pooling, we have three types. We have max pooling, we have average pooling, and we have min pooling. What is a max pooling? Among these, the highest value is 9. Among this, it is a 2. Here it is 6. Here it is a 3. So this is what is max pooling. What is average pooling? It will add 1, 3, 9 and 2 divided by 4. 2 plus 1 plus 1 plus 1 divided by 4. So that is average pooling. And what is minimum pooling? Minimum among. Minimum among this entire is 1. Minimum among this entire is 1. So these are different types of pooling. So let's understand here. So this is the output of a convolution and a ReLU. Now pooling, we have used max pooling, and here the window size that we have fixed here is 2 cross 2. Now 2 cross 2, this first, this is the window. So among this, the maximum value is 1. Now stride it. So when you say window size as 2 cross 2, definitely it will leave a 2 and it will go to the next 2. Among this, the maximum is 0.33. Among next, the value is 0.55. Okay, now you come here. When you take this, we don't have the values. By default, the value will be 0. Among this, the maximum is 0.33. So now, if you continue this, look at what we have got. Have you lost any information here? This is this primary diagonal you see. Whatever are the, this in the X, you have extracted this part. Now, when you go, by performing the pooling, is it not you have still retained that? You look at the primary diagonal, diagonal value, primary diagonal value. Is it not you have still retained that X diagonal? Only thing is you have not taken the entire. You have considered only the most important. This is called, pooling a layer. By default, here the window size will be, the size of the window will be 2. If you don't specify the stride, the window size will be the stride size. Default will be the pool size only, window size only. No, you don't want 2 cross 2, you want to explicitly specify, then you have to write this stride here. You need to explicitly specify this stride. By what will be the formula to calculate the max pooling, the pooling layer output? This is the formula to calculate the pooling layer output. Here it is once again the floor. If you take this as an example, if you substitute the values, you get finally the output size as 3 cross 3. So I'll be sharing the slides with the organizers. They'll be sharing it with you. You can practice these. This is the last topic I have. Sujata ma'am, do I have another 5 minutes time?
Sure, ma'am. We'll continue.
Okay. Yeah. So we have an input, summarizing, we have an input. We have performed convolution, ReLU, pooling. And if you have used 3 such kernels, then we get, first kernel getting multiplied with this, performing the entire operation. Second kernel performing convolution operation, then ReLU, then pooling. Is it not? We get this output. Now, you can ask the question, ma'am, after this, can we then pass it to a flatten layer? Now, what is flatten layer? Flatten layer is converting something in a matrix to a single vector. So now when you convert this into a single vector, this is the size of 4 cross 4. 4 cross 4, 4 cross 4, 4 cross 4. So is it not still the size is more? I'm sorry. Is it not still the size is more? So we don't want, so much of size to go into an fully connected. So then what we'll do, we'll again repeat an convolution, ReLU and pooling. Again, we repeat these layers. Now, when you repeat, you just see again we are using the three kernels. So the first, all these three kernels will be performing, you will perform it on, or the first kernel on all these, you will get one matrix. The second kernel on all of this, you get one matrix. The third kernel on all of this, you get one matrix, right? Or the first, matrix multiplied with all these three kernels, perform element-wise multiplication, summation, you get a 3. Again, you perform an addition, you get one matrix. So finally, you get this output. So now, first you have taken the input, you have passed it to one set of convolution ReLU pooling, you got three such feature maps. Since the size is very large, you have again applied one more set of convolution ReLU pooling. Again, you have applied a kernel, you got some output. Now, this time the output is definitely a reduced size comparing to just one set. Now, the last what we have is a flattened layer and fully connected. What is a flattened layer? It is converting multi-dimensional output into a single vector. So if you have a feature map something like this, flattened layer will give you one single vector. If you have multiple such kernels multiple such feature maps, when you flatten it, you flatten in this way. I hope you're getting it. Why are we doing it? Because once we flatten it, we'll be passing it to fully connected. If you apply, after the first, you have 48 neurons here, because 4 cross 4, 16, 32, 48. So totally 48 such neurons will be there when you pass as an input to fully connected. If you apply one more set, definitely you have reduced the size here. Now you just have only 12 neurons. Why? Because there are only 2 cross 2 and 3 such matrix. So 12 neurons. Thus 12 neurons are then passed to fully connected. So fully connected, when you pass, this is responsible for classification. In our human, it is the, IT, inferotemporal cortex. So it is IT what it performs. So this is what is then the most important is there is something called as global max pooling and global average pooling. Now, what is this global max and global average pooling here is, now, see here, we have got three such matrix. This is the first, second, and the third one. And here also you got 1, 2, and 3. We have 48 neurons, we have 12 neurons. Still, if you feel the size is very large, then we have something called as global average pooling and global max pooling. What is these two? Now, what I'm talking here is those matrix. If you have 3 such matrix, 4 such matrix. Now, if you are applying it to, global average pooling. What is global average pooling? Take the average of all of these values. 3 plus 1 plus 1 plus 3. You add all these values divided by how many values are there? 4 cross 4, 16. So divided by 16, you get only one single value. Then you have a second such kernel, a second such matrix. Add up all those values divided by so many, whatever is the number, you get one more value. So what I'm trying to explain you here is, here we have 48 neurons. We don't want 48 neurons to be passed. Now, from this you can just get 3 values. How can you get these 3 values? Can you add up all these values and divide it with 16? Can you add up all these values and divide it with 16? Add up all these values, divide it with 16. So how many values we get? We get only three values. So after you flatten, when you pass it into fully connected one, here we are not passing 12 neurons or 48 neurons. We are just passing the three feature maps. There are only three values. I hope you have understood this. So this is global average polling. Then we have global max polling. What is the max? Among this entire, what is the maximum value? So again, maximum value is 1. Among this, the maximum value. Among this, the maximum value. Here, we are drastically reducing again the features. So it has its own impact on the performance, but there are some special CNN architectures which are going for global average pooling and global max pooling instead of flattened layer. It is if you go for an implementation, instead of a flattened layer, we go for global average pooling. So either go for flattened layer. If you go for flattened layer, number of neurons, input neurons will be more. If you go for global average pooling or global max pooling, you are drastically reducing. That is what you see here. Whatever may be the size, you are ultimately reducing it to 1. So that 1 is either average value or it is a max value. So some special CNN architectures uses this. So this is all. I have still not completed. I have come to thank you slide. I want to show you. There is one concept which I want to show it to you. Can you able to see? I have opened one website. Sujata ma'am, can you able to see this website? I
No,
have
ma'am.
opened.
Only slides only visible, madam. No
Slides
picture.
only are visible. Okay, okay, ma'am. I'll just share it once again. I think now it is visible. Okay. So why it is important for us to know the math behind and why, uh, um, s- the architecture is being explained to you. Now, whatever are the different variants of CNN, it can be VGG16, AlexNet, GoogleNet, Inception, ResNet, DenseNet. There are multiple, every day we are coming out with the new algorithms, new architectures. If you see, all those are the different variants of CNN. Now, if I ask you to explain me this architecture, you'll be in a position to tell. When I write 3 cross 3, is it not, it is a 3 cross 3 kernel? And 64 such kernels we have taken, and it is 3 cross 3, 64 such kernel. So what is this VGG16 architecture? They have first performed two convolution operation, convolution ReLU, then they have performed the pooling operation. And what we have seen in this, I'm not sure whether you can able to see the screen. Okay. Um,
It is visible, madam.
yes, ma'am, I'm just showing here. Okay. When you see this, it is, we have passed an input, we have performed a convolution, ReLU, then immediately we have seen pooling. What they have done is first they have performed convolution ReLU, again convolution ReLU, then pooling is applied. So once we understand the basic architecture clearly, then understanding other architectures becomes very, very easy. Now you see how VGG16 is being built. They have used the two convolutions followed by pooling, again two convolutions followed by pooling, two convolution layers followed by pooling, three convolutions followed by pooling, three convolutions followed by pooling. Then they have used three fully connected layers. This is how the architecture has been built. Now, on what basis we can select the number of kernels? It is purely a trial and error. Here they have used 64 kernels, 128 kernels, 256, 512 kernels, 512 kernels. This is a purely an trial and error. There is no math behind to tell what should be the correct number of kernels. So now once VGG 16 was implemented, the same research team has come out with VGG 19. How did VGG 19 has come up? For the same existing VGG 16, they have added, three more layers. Three more layers have been added. Now, where are those three layers is been increased? Can you able to see? Here it was three, but now they made it as four such layers. For one more additional convolution layer. Here there are three, and here there is one more additional layer. I think this particular, if you go into some other website, you'll be able to see here also they would have increased. They have increased one more layer. So why not? Let's go back and then search for VGG 16 and 19 architecture. Yeah, if you see this particular, you will be able to see the difference where there are here they have increased one, here they have increased one, and here they have increased. So understand the architecture thoroughly so that you can play around with CNN architectures. You can keep increasing the layers, you can fine tune the number of kernels, and you will see how the performance is varying. Next, you can ask one more important question. Why is that we should understand that math? What is that math? What is the output size after every layer? After convolution, what is the output size? See, can you able to see here how they have given the architecture diagram? Most of us here are the faculties. Definitely, you will be coming out with your own. Maybe many of you are a new researchers who may be starting your research journey. You have to come out with your own novel architecture. So in that case, you have to propose an architectural diagram in your research paper, something like this. One more example I can give you. Can you able to see this diagram? Okay, can you see this diagram? So how they have written the dimensions here? How did they get these values? This is what is the math formulas that I was discussing about. So a novel architecture, when you are writing in your research article, you have to come out with your architectural diagram also. You can come out with a diagram, something like this. Yeah, so this is all what I wanted to share with you. The CNN architecture has been explained in detail and then shown you the variants of CNN architecture. The variants of CNN architecture is just playing around with the number of layers and the number of kernels, the parameters, the stride size, whether they have included the padding or excluded the padding, what is the number of kernels they have used, whether they have used batch normalization or not, if at all if they have used dropout, what is the percentage. All this is just the hyperparameter. You can come out with the architecture. So with this, I'm stopping my presentation. I'm going back to the slides and then I'm open for the questions. First, let me see the chat to see if there are any questions here. Concepts are
Actually,
clear.
there are three questions, ma'am.
Why kernel matrices are not same? Anupama, ma'am, that's a question to the class. I'll be coming back on 10th. So 10th, if you can able to answer, it's fine. Or otherwise, I'll be answering this question on 10th. How to select kernel elements? Okay, the kernel ma'am, if at all, if the concept of ANN is clear to the participants here, see, kernels, weights, and bias are something which we will ask the model to assume. So when we ask the model to assume, initially during the training, you will be going in the forward direction. You will do the computation. You will allow the model to predict. Once you predict, you will calculate the loss. Once you get the loss, when you compare with the ground truth, you will be calculating the loss. If the loss is too much, what you will do? You'll back propagate. Why is that we will back propagate? To update the weights bias. So here, what are those weights and biases for our CNN? Definitely the weights and biases for our CNN is during backpropagation, we have fully connected weights. Further, if you backpropagate, we have kernels. So initially, to answer to your question, randomly the model has assumed some values. Later, during backpropagation, we are, updating these kernel values. Over a period of time, after certain epochs, we will have the most optimized kernel, which means the kernel which is ready to extract the good features. Then during a testing phase, you pass one image. For that image, this optimized kernels will extract the features and it will give you the prediction. I hope I have answered to your question, ma'am. Um, Detailed explain. Okay. Ma'am, I was able to see two questions. Why can't we use artificial neural network for the images? Vinod sir, artificial neural network cannot be used for images because for ANN, you require a data in a single vector. But we have a data in terms of a matrix, which is two-dimensional one. So two-dimensional, when you convert it into a single vector, we are losing its spatial information. We are losing its local dependencies and the parameter exploration. That is the reason we cannot. What is the difference between spatial information and temporal information? Can CNN extract temporal information? It's a good question, Nitya ma'am. So, spatial information is the positions of the pixel values. And what is the temporal information? Temporal data is where there is a dependency. Yeah, CNN can extract both spatial and temporal information. Yes, it can extract both. Uh, um, tem Temporal information is a spatial information. So that's the answer. Which deep learning technique can be used for audio data, which is in .wav or MP3 files, and why? Sir, Srivatsa. Yeah, Srivatsa sir, for any audio, video, we have a sequential data. All these are sequential data. So for sequential data, we have RNN and LSTMs. And why? Why? Because there is a dependency, right? When there is a dependency, when you have to process the next information, you have to consider its previous data also. So that ANN, CNN cannot do it. That is the limitation. Although CNN performs exceptionally well for images, it cannot process audio, it cannot process video files. In order to perform video, we have to go for LSTM, convolutional RNN or convolutional LSTMs. That's the answer. Ma'am, do you know the difference between LQNN? What is LQ? If you can tell LQ, I can able to tell whether I know or not. Some research has been done on LQNN. I'm just surfing what is LQNN and then I can tell you. Yeah. So I have some message from the organizer. Uh, okay. I will be coming back on 10th again. So we will take up the questions on 10th. I think you have your next session. We'll move to the next session. Thank you so much. And thanks for the organizers for having me today. Thank you.
Thank you very much, ma'am,
Thank
for
you,
the
ma'am.
insightful and engaging session on CNN architecture. Your lucid explanation and explanation of concepts and practical insights and examples have greatly enriched our understanding how CNN technique can be effectively applied in images, and so that we can apply it for healthcare applications. So the session was highly informative and extremely beneficial for all the participants. We can see positive responses in the chat box also. So, on behalf of
Yes.
AICTE Atal Academy at the CDT Institute of Science and Technology, I sincerely thank you for sparing your valuable time and for sharing your expertise with us. We truly appreciate your contribution to this program, ma'am. We are looking forward to future academic interactions also. Thank you very much,
Thank
ma'am,
you,
once
ma'am.
again.
Thank you, ma'am.
Mhm.
Thank you all. We'll meet
We'll
on
meet again
10th.
on 10th, ma'am.
Sure, ma'am. Yeah, thank you.
Yeah. Dear participants, please be active. Another eminent person is also waiting for the next session. So we'll start the session in 1 minute. So once again, good evening to all. Um, Now I'm delighted to introduce today's distinguished resource person, Dr. Pavan Kumar C. Dr. Pavan Kumar is currently serving as an assistant professor at the Indian Institute of Information Technology, Dharwad. He has rich academic and research experience in the areas of artificial intelligence, deep learning, and modern computing frameworks. His teaching and research interests include deep learning frameworks, TensorFlow, Keras, and practical AI implementations with a strong focus on bridging theoretical concepts and real world applications. He has actively contributed to academics through quality teaching, research publications, and hands on technical training programs. We are privileged to have Dr. C. Pavan Kumar with us today to deliver a session on deep learning frameworks, introduction to TensorFlow, Keras, and Google Colab, which will provide valuable practical insights to all of us. Sir, handing over to you the session, sir. Please commence the session.
Yeah, thanks, ma'am, for the generous introduction and also for the invitation for this faculty development program. Hope my screen is visible, right? If I'm not wrong.
Yes, sir. Screen is visible. Your voice
Yeah,
is clear, sir.
yeah, okay, fine. Thank you. And then, like, see, today's talk, it's like on the introduction to like Collab, Keras, and all. These are all the, like, what you can say, they're all the collaborative tools that are readily available for us to implement some of these machine learning algorithms or deep learning or anything in Python, you can do it at ease. See, like probably like you may be using now Google Docs extensively in many of the applications, and then like we know how collaboratively we can write or edit some documents. So just what I thought is like just before introducing this collab, I'll just give you some brief insights on like what is the kind of the things, kind of work the people are doing here in the case of machine learning, and then we'll come to the like collab environment, and then we'll try to implement those, and then we'll see what are the things that are associated with it. So in the today's talk, I will be just trying to discuss briefly on understanding the poisoning attacks on the machine learning. Like probably people are talking, everyone is talking about like how is this machine learning, and then like what are the advantages of it. But also on the other side, like what will happen if we don't properly train the machine learning algorithms, and what are the side effects we may face if we don't do it in a proper way. So that we'll try to discuss first, and then we'll go to the collab environment, and then we will try to see how the performance and other things will vary if these machine learning algorithms are subjected to the poisoning attacks, right? So this is the outline of the talk I would like to give in this presentation. First, we'll see what exactly is a machine learning is, and then we will see like poisoning attacks, and then types of the poisoning attacks, and some real-time examples, and like what are the algorithms that can be used to overcome these poisoning attacks and advanced defense techniques, and then case studies, and then like we'll go with the conclusion and takeaways. In the case study section, we'll go to the collab, and we will try to implement these things. Hope I'm audible, right? Clearly, just to uh,
Yes, sir. Yes, sir. You are audible.
yeah. Okay. So in general, to give an overview of the machine learning, so machine learning is important for several reasons. Like people are talking about machine learning nowadays, like from last few years. Like one is for the data analysis. That is, machine learning algorithms can analyze vast amount of data, like quickly and efficiently, and also like it will uncover the patterns and insights that would be difficult for the human beings to detect. Like when the amount of data, like earlier we used to handle was in Excel sheet, or like to some extent it was in CSV files. Now it has become like, in the sense, if you take a data set, if you take in terms of the rows and the columns are so high, that means the features are also available so high, and as also the rows are also very high. Like the number of rows and columns are high means it's an high dimensional data. Like handling such data by using the traditional tools, it will become very difficult. So we need to go for some like algorithms to identify the hidden patterns from that and other things. Right now, coming to the another aspect why it is required is the automation. Like when you say it is an automation, when we say like automation, just a second. Yeah, by automating the repetitive task, machine learning frees up the human time to focus more on the complex problem, increasing productivity across various industries. Nowadays, people are talking about automating the things, and also like whether we can do the repetitive task by the help of the machine learning. Probably some of the terminologies you may be familiar with, the vibe coding, right? Like vibe coding or copilot. Why are they used? Like just to do this kind of task. Next is ML enables the personalized experiences in fields like marketing, e-commerce, and then entertainment, enhancing the customer satisfaction by tailoring the recommendation and services. Probably if you are searching something on the Amazon, the next moment you will get something as a recommendation. Based on what they will give you the accurate recommendations. It is not just by your profile data or like search history. It is like an comprehensive things. Like it will take from your previous history, and also like multiple factors will be depending on that. Next is the predictive capabilities. Like when it comes to the predictive capabilities, it is a quite important thing nowadays in many sectors, not only in the case of healthcare, not only in finance, in every sector it has become a very important aspect is the predictive capabilities. How we do the predictive capability, like if you are having a time series data, that means the sales of the data from so and so, will it result in a like increased sales in a particular duration? That will not be a thing, right? So now that is not only dependent on that, it's not a linear factor. If that was the case, then people would have predicted stock market to the next level by this time, right? So it is not that easy to do the predictive capabilities, but can the machine learning can do it? That is also very difficult. Now another is the innovation is the factor. Like it drives the innovation in diverse fields such as healthcare. when we talk about healthcare, it is about diagnosing the diseases and then like financial fraud and autonomous system. Like if you take the self-driving cars for that matter. Now, like real-time decision making is the another way, which is having a lot of application in the network intrusion detection systems. Because as you know, day by day, lot of malware and then like even viruses or trojans are getting manufactured, and that payload will be dumped onto the user machines. They are also called as zero-day threats because there are no known algorithms that can handle these kind of threats, right? In that cases, these ML systems can be very helpful so that they can analyze the data in real time, allowing for quick responses in the critical situations, such as in cybersecurity or emerging emergency services. Next is, as you know, like in the scientific research, the ML can identify these correlations and insights in complex data sets, accelerating discoveries in areas like genomics or climate science. It will also help in such cases like now in the climate science, as I was talking about the stock market, it is also not very straightforward, right? There should be like various things or various multiple factors that do exist, but till today we are not able to give a correct model which can predict things correctly. And the other important aspect is the genomics, where in case of the genomics, the human genome sequences, we don't know why some particular person will get some disease at particular point of time in his lifespan, or like why he will not get the disease, because all are human beings and all are made of the chromosomes. But what is that, like few are likely to complete some 60 years, why some are able to complete till 80 years? We don't have any accurate answers for all these questions. But now like machine learning people are trying to do, like whether they are able to like understand the human genome sequence and then try to get more data into it. So like what we can say is the machine learning is transforming multiple industries. It is improving the efficiency. Probably like you may be by this time you may be knowing, right? Like how the machine learning is taking or machine learning or AI in general is taking place or taking space in our day-to-day lives and enabling the new technologies, making it a cornerstone of the modern innovation. So for this like topic which I was talking about, the poison attacks, first we'll try to briefly see how this machine learning works, or what is the thing that is required in the machine learning. So first thing is the data collection. It is a quite important step in the case of the machine learning, or for example running any AI algorithm, because data is the one based on that you are going to do the your predictions or whatever your future task. The first step involves gathering a large amount of data relevant to a problem you want to solve. Like now you are trying to this data can be structured like in the spreadsheets or unstructured like in the images or text or in the video. So like for example drone images, right? Now drone images you are going to collect, but how do we process it at a later stage, right? That's one challenge we do have. Now when we are taking a port address and then like we are collecting the traffic from that port continuously, now what to do with that data next, right? Whether are we doing or are we like following the standard practices that to be kept in mind when you are collecting that data, that we need to check, right? Next is the data pre-processing. This is a quite important step in this machine learning. The collected data often needs to be cleaned and then prepared. This can involve handling the missing values and then normalizing the data and converting this categorical variables into the numerical one. Probably you might have worked on simple things by this time so that you will understand what exactly this data pre-processing is. Next is choosing a model. Now, depending on the problem which you are going to work on, that is like whether it's a classification, whether it's a regression or clustering, you choose a suitable machine learning model or an algorithm. And then common types include this decision trees, neural networks, support vector machines, and so on. Probably we will not get into these details like what exactly these are, but just you might have heard the names. So this is how the standard practice is. Next is the training of the model. So the selected model is trained using a subset of data, and during the training, the model learns to recognize the patterns and relationships in the data by adjusting its parameters to minimize the errors, right? So this is what we have seen in your general things. Next is how this ML algorithm works. Like that. Next to the validation and tuning. Like after this part, just a sec. training the model. The selected model is trained, and then it's the validation and tuning part, wherein the after training the model is validated using a separate subset of data that is called as validation data also to ensure it performs well. And these hyperparameters may be adjusted to improve the performance. Next is testing the model. Like once we have done it, then how do we test the model? Then it is tested on another distinct subset of the test data to evaluate its accuracy and generalization to new unseen data. Next comes the part where is the deployment, right? Probably like if there are academic researchers, they will stop at this point of testing the model and they will not get into the deployment mode. So in the case of the deployment, once satisfied with the model's performance, it can be deployed in a real world application to make the predictions or decisions based on the new data. But are we done with the deployment? Because it's a continuous process, and then the data patterns may change, user behavior may change. In such cases, how do we do it? Or the disease symptoms or the disease representation may change. All this, how does it work? Next is monitoring and maintenance. So after the deployment, the model's performance is monitored over time, and it may need to be updated or retrained as new data becomes available or if the underlying patterns change. That is another thing, right? It may be updated or retrained as new data becomes available. So, like machine learning involves a cyclic process of learning from data, refining models, and applying them to the real world problems. Probably now you've got an idea how does this machine learning works. In simple, it is something like you collect the data and then pre-process the data. If there is class imbalances or something like that, then just try to see that how you balance the data and then choose the right model. Once you have the right model, then try to see whether you can train and test the model and then go with the deployment. Once it is deployed, just check whether whether continuous updates are required or continuously fine tune the model or what is required. That is the next step. So that's an overall machine learning life cycle is, or like we can say, machine learning algorithm works. Now, what do you mean by the poisoning attacks, or why they are important in this case of the machine learning? Do they are they significant enough, or like can they be ignored? Right. So this poisoning attack occurs when an adversary intentionally manipulates the data used to train the machine learning models by injecting corrupted or malicious data. Like I'm just reading out the definition. Why? Because like this poisoning attack means now the as we seen in the previous case when we were discussing about the machine learning, we have seen that this machine learning algorithms are trained over the data set, right? Or like the data which has been collected. If someone intentionally manipulates the data, which is used to train the machine learning models by injecting the corrupted or malicious data, it will be an example of it. Now, why are they dangerous? Why such case of a malicious data or the poisoning of this data set is dangerous? Because these attacks degrade the performance of the models and compromise the predictions and can be particularly dangerous in high stakes applications like finance, healthcare, and autonomous vehicles, and also in the security applications, right? Now, in the finance, like suppose say if you are getting a false uh, like a recommendation saying when the market is low, then people will tell you to sell, so that incurring huge financial losses. In the case of the healthcare, we know if any like benign and malignant cases will be there, and if there is a malignant case, if the model like falsely take it as benign, then we are gone case, right? Similarly, in the case of the autonomous vehicle, that is again we have the same problem. Like when you see the traffic signal, the challenge is like when you see a traffic signal, it is required to act based on the signal light. If it is red, we need to stop. If it is green, we need to go. And then if it is yellow, we need to make sure that like our vehicle is in the idle state, not moving. Right. Now the thing is like if the model is trained in the other way around, saying that like speed up the car when you see the red light instead of slowing down, right? Then it can result in the fatalities. Right. Similarly, in the cybersecurity applications as well. So poisoning attacks can manipulate the training phase of the machine learning models, so causing them to learn some sort of an incorrect patterns, and they are dangerous because they can lead to the costly mistakes as well. especially in critical systems like medical diagnostics or the autonomous vehicles. Next is how does this poisoning attacks works? Like what is the attack mechanism they generally adopt? So, like an adversary gains an access to the data set or injects the malicious data. Like assume that they has got the authorization and then like also authentication to inject the data. An adversary will inject some data into the data set. Then the model learns this incorrect or the manipulated patterns over there. Then the compromised model performs poorly either globally or selectively. When I say it is globally means across all the predictions it may be doing bad, or it is selectively on the specific targets. Now, what is going to be the objective of the attacker in such cases? To cause the specific misclassification, that is for sure, that is called as the targeted attack. As I was telling about the benign and the malicious ones, right? Like if you are having the benign ones, like if you are misclassifying it as a malignant, then you are almost doing the reverse. And to degrade the overall performance, that we know like there's an any attack, it is just to make the performance low or throughout the system from the legitimate users. So what we can understand is poisoning attacks generally happens during the training phase, and also it makes it difficult to detect once the model is deployed, because like once the model is deployed, it's commercialized and it is in use, people think that the model might have done already the testing phase, all the phases, then we can go with the deployment. Now, an adversary injects this manipulated data, causing the model to behave very incorrectly. For example, in an autonomous vehicle scenario, the model could misclassify a stop sign as a speed limit sign. As I was telling, like when you see the red light, instead of stopping the vehicle in an autonomous vehicle, instead of stopping, it will come to a lower speed. Say, instead of if it is at 70 kilometers, it will slow down to 30 kilometers, but still it will move, but it will not stop, right? So next is what are the types of the targeted attacks do exist in this domain? Poisoning attacks do exist. One is the targeted poisoning attacks. Like in the case of the targeted poisoning attacks, like it will affect only the specific instances or the patterns, forcing the model to make errors on particular data points. It will not do on everything. So it is only when a particular use case or a particular criteria is set, then it will trigger the poisoning attack. That is called as a targeted poisoning attack. So one of the examples for this is an adversary tampers with the facial biometric system training data so that it misidentifies a certain individuals while performing correctly on the most others. Right? Probably you might have seen this in some of the movies nowadays, in sci-fi movies. Like how do they show is you can misclassify, like you can use a like you say face mask, or like you can like instead of your face I'll register my face, and then like when you recognize, like instead of your face I'll always recognize with my face. So it is also an example of a targeted poisoning attack, because the machine learning model is trained on the original image, but I have inserted a duplicate image and trained on the duplicate image itself. Next is the indiscriminate poisoning attack. It will degrade the overall performance of the model across all the input. It is not selective in nature. It will be done only to like make sure that the system is not working properly. In this case, an attacker injects noisy or incorrect data into a sentiment analysis model, leading to overall degradation of its predictive performance. Like, for example, in your natural language processing, if you are giving some statements and if it is degrading the quality of your assessment based on what the speaker is intended to do, then this is the challenge. Now, in targeted attacks, the adversary has a specific goal in mind, such as causing misclassification or, no, sorry, okay, right, has a specific goal in mind, such as causing a misclassification on particular inputs. In contrast, discriminate attacks aim to lower the model's overall accuracy, making it unreliable. So, what are the some real-time examples we will see in this domain? One is the autonomous vehicles, which I was talking about. So, what are the poisoning attacks can lead to in this case? One is the signal, right? So, this poisoning attacks manipulate the images or the sensor data used by the autonomous vehicles perception system. See, if you are using a dash cam, for example, and you are capturing the signals at the stations, at the junctions where the signals are deployed or signaling system is deployed. Now, this poisoning attacks manipulate the images or sensor data so that when it reads that image, instead of stopping it, it understands that, okay, I need to run now or rush through now, seeing a red light. So that is one challenge here. A car could misclassify the traffic signs, such as mistaking a stop sign for a yield sign, causing the dangerous driving behavior. Healthcare data, as I was talking about, like medical diagnostic systems are poisoned by injecting the fake patient records or incorrect diagnosis, right? Like if you are completely dependent on the machines to diagnose or like to give the some sort of an treatment, then there may be a case that by injecting the fake patient records or incorrect diagnostics, it may lead to some issue. Now, this healthcare, the model might give inaccurate diagnosis, but leading to incorrect treatments, this delayed interventions, or even misdiagnosis of this life-threatening conditions. Now, these poisoning attacks can be catastrophic in autonomous vehicles, as you know that, where safety is paramount, and also in the healthcare also it is important because diagnostic systems is vital and any treatment doctor wants to give based on this diagnostics can lead to a fatal thing or can have a life threatening consequence, right? Like you may be treated for some illness for which you are not even having it. Right, that is one of the challenges that we may get if we use it, if we are like subjected to this kind of poisoning tax. Another is the finance and the high frequency trading. But anyways, this is also one of the important use cases. Like an attacker introduces this false stock prices or trading volumes into the data set used to train it. And as a result of it, what will happen is like selling of assets prematurely or making unnecessary purchases is a problem in this case, causing financial loss. And next is the recommender systems, right? Like recommender system, like when you recommend some products, an attacker creates fake user profiles or inserts biased reviews into a recommendation engine's training data. Probably like all of us are victim of this recommender systems one or the other time while purchasing the goods e-commerce sites. Like sometimes we say on the e-commerce site the reviews are good, but when we purchase it, the product is bad, right? Because we don't know who has implanted those reviews, and then like based on that has resulted in our purchases leading to a financial loss, right? That means the poor quality of products or services harming the trust. So what we can say is like a slight manipulation of the market data can lead to huge financial losses or disruption, whereas the poisoning recommender systems could degrade the quality of recommendations, affecting the user experience, user experience and the business outcomes. So next, another is the federated learning, wherein a system where multiple devices get train locally, and the global model aggregates the updates from each device. So like probably you might have heard of the name federated learning, right? In the case of the federated learning, what will happen is instead of sending all the data to the single location, so if you have checked this machine learning, like how does it happen? I explained to here that the data is collected at a single place, the data collection is done, right? Gathering of large amount of data will be done at a single place, and then the machine learning algorithm works. So instead of that, if you do the learning distributedly, that means you can have the clients or multiple clients and make the local models and the global model, and let the local model learn at these client location and send the updates to the global model, then it can work like a charm, right? So here the federated learning works in the similar way, wherein you will not be sharing the data with the, we'll be not sharing the, just a minute, I'll go to the respective slide. Here, in the case of the federated learning, we will not be sharing the actual data with the global server or at a centralized location. Now, think of an hospital collaborative system. Multiple hospitals are available and they want to learn about use machine learning algorithm, and then they want to learn about a particular disease. But none of them are ready to share the data to a central location. So instead, what can we do is we can use the federated learning model, wherein a global model will be there, which aggregates the updates from the local models, and local models will be there in the local hospitals wherein the data is present. Now, this local models will learn from the data which is present in the hospitals, and it will send the updates to the global model, and the global model will learn from this, and then it will take a decision. So that is one of the example of the federated learning. But now the challenge is in this also there is a case wherein if the local devices are compromised in nature. So a compromised device can send the poisoned updates, corrupting the global model without directly assessing the entire data set. Next is the Byzantine failures. When one or more multiple devices send these malicious updates in a distributed environment, it causes the global model also to fail. So in the case of federated learning as well, the updates are sent to a central server for aggregation. And if an adversary compromises a single device, they can poison its local training data and send the malicious updates. So now we are convinced in a way that like we need to avoid this poisoning kind of an attack, or like poisoning data or poison data getting injected into the data set, so that like we are not what to say we are not the victim of the poisoning attack. Now the next challenge is what are the steps that do exist in overcoming these kind of these poisoning attacks. One is the data sanitization technique, and next is the robust learning algorithms, and next is the adversarial training, right? And then the differential privacy comes. Like then we will see some use case with the differential privacy also, how we have used the differential privacy to overcome in the case of the to overcome the poisoning kind of an attack in the internet of medical things. And also like we'll see data sanitization technique, how if we don't perform it, like how the model performance degrades in the collab, right? So next in the case of the data sanitization technique, probably you may be knowing it. So one of the ways to data sanitize the data is the outlier detection. So this outlier detection identifies and removes the abnormal data points that deviate significantly from the rest of the training set, right? Like now, if we are collecting the training data over 100 vehicles, if some 10 vehicles are speeding up when they see the red line, then we a red signal, then we can consider them as the outliers, and then we can remove them from the training process itself. Similarly, it is applicable to the healthcare domain also, wherein in the case of the healthcare domain, if there is a misclassification of the benign as malicious or the other way around, then we can remove those examples, and then we can go with the further steps. So one is the isolation forest. So this algorithm isolates the observations by randomly selecting the features, and then randomly selecting a split value between the minimum and maximum of values of the selected future, and it can construct a tree structure where outliers are isolated. And next is the k nearest neighbor. Probably you might have heard of this algorithm where the outliers are detected by calculating the distance between the data points. If the point is far, that means the distance is high, right? So if a point is far from most of its neighbors, based on the Euclidean distance or Manhattan distance or any other distance, if you compute, it is flagged as an outlier. So it's another way to do it. Next is probably density-based spatial clustering of applications with noise. In this clustering algorithm, one can identify the low density regions in data by analyzing the distance between the point. Yeah, probably I can show you this as well, wherein we have used this DB scan in the network intrusion detection system, and we have showed that this DB scan can be employed to come up with how do we address the zero day attacks in the network intrusion detection systems as well. So these techniques help to clean the data, removing the anomalies before the model sees them, and this prevents the training process from learning the false patterns caused by the poisoned data. Next is the clustering based algorithm, like we have seen the KNN. Similar to that, in the KNN, we are just calculating the distance there. But whereas in the data clustering methods, like clustering algorithms like K-means or hierarchical clustering are used to group the data points based on some similarity. Now, this poisoned data may form a distinct cluster and can be separated from the legitimate data points, right? So that's one way, easiest way of doing it. Now, clustering of the features like pixel intensity or texture can be used to cluster the images. Now, this poison data, such as image with slight but harmful alteration, may fall into these distinct separate clusters, forming a thing. So this is one way we can do it based on the clustering. Next is the robust learning algorithms, right? Trim mean aggregation, wherein you will take the mean of the values and then like which are falling away from that, then we will remove them. So in the scenarios where the model is trained on a distributed data, that is on a federated learning, what will happen is each device will send updates to the central server. So instead of taking the average of all the updates, trimmed mean removes the highest and the lowest values, that is the potential outliers, and averages the rest. Right. So as I was giving an example, if you take the upgradation process over the 10 clients and two send the poisoned updates with extreme values, the server can remove those two values and then they can consider only the middle values. This is also another way it can work on. So this method is resistant to the attacks where a client or a data point send malicious updates, as it reduces the influence of the outliers on a personalized sample. Sorry, I skip to the last slide. Just a second. Uh, just a minute. It's talking about this. Okay. Uh, Sorry for that. Yeah, trimmed mean like as I was giving. So next to the median aggregation, instead of like here in the case of this mean, we will be taking the mean value and we will doing the aggregation. But here we will be taking the median value and then we will be doing the aggregation. Right. Next to the Byzantine resilient algorithms, like in a distributed or the federated learning setup, some clients may behave maliciously. That is, the Byzantine failures can happen. And now these algorithms use this advanced filtering mechanisms to detect and discard or say poisoned or the faulty algorithm. So what we'll do in the case of the Byzantine resilient algorithms is they apply a consensus based method to agree on which updates seem the trustworthy. Like they may discard the updates that significantly differ from the majority or use majority voting to identify the suspicious behavior. Probably like if you're working with blockchain, there also we work on a consensus mechanism where if you're writing some transaction onto the block, right? If multiple majority stake, that is the proof of work or the proof of stake, if they agree on the writing a transaction to the block, then only in consensus it will be written to the blocks with a replica in each block, right? So similarly here also, like in the Byzantine resilient algorithm, they apply a consensus based method to agree on which update that significantly differs from the majority or use the majority voting to identify the suspicious behavior. Now, these algorithms like Crumb or multi-crumb, which select the updates closest to the majority and then like discards the extremes, or examples of this resilient, Byzantine resilient strategies. Now, these algorithms protect the distributed learning systems from the poisoning attacks, ensuring that even if some clients are compromised, their influence on the global model is minimized. How it works is generate the poisoned example. So in the case of the, yeah, next is, just a second. Hope I'm audible, right? Clearly. Can anyone tell me if I'm audible clearly? Just in the chat box. Yeah, okay, fine. Thank you. Just know in some sort, like sometimes in this online talks, we need to ensure that otherwise it will be difficult when you're giving a full screen presentation. Yeah, next is the adversarial training. Right, adversarial training, probably you may be knowing it. So how does it work is in the case of the adversarial training, so while training the model itself, like train it with some poisoned examples so that there will be no need in further. So in adversarial training, the training data is intentionally perturbed to possibly simulate the poisoned attacks. These perturbations may uh, include adversarial examples or fully poisoned data points. So the machine learning algorithm, what it will do is it will yeah, uh, can- okay,
Sir, PPT is not visible, sir.
is not visible.
Yes, sir.
Oh, second, just will reshare it.
Yes, sir.
I think, are you sharing the screen or someone is sharing the screen? Because I think Sumita Chandran is sharing the screen. Can I just okay, right. Yeah, can you see my screen now?
Yes, sir. Now it is visible.
Okay. Probably like multiple people are allowed to share the screen. That's why it was a problem. Okay. Now, in the case of the adversarial training, what we'll do is uh, we will first create some poisoned examples, and we will make the model to learn with this poisoned example. So the training data is intentionally perturbed or to simulate the possible poison attack, and these may include adversarial examples or fully poisoned data points. So, like this poison data is mixed into the training set. It's something like slow poisoning, and the model is trained to correctly classify both clean and the poisoned is the poisoned inputs in future. Probably in mythology also you might have studied these techniques wherein a slow poison is given to a person so that they will develop the resistance. So it's something like maybe inspired by that model. I am not very sure. But anyways, this adversarial training is just to make sure that the model learning or the training which we are going to do will also include some poisonous input so that the model will neutralize or overcome this uh, poisoned inputs. So in the case we images with minor pixel modifications that can cause the misclassification, and the model is trained to correctly classify these altered images, making it resistant to future attacks. So adversarial training advantage is it makes the model robust by exposing it to potential attacks during the training phase, and as a result, the model becomes more robust to the unseen attacks. Right? What is the a real-time example is in healthcare diagnostics. An adversary may inject manipulated medical images, that is, scans with slight pixel changes that alter the diagnosis. So now with the adversarial training, the diagnostic model is exposed to these poisoned examples during training, making it less likely to fail when encountering the similar attacks. Next is another is the differential privacy. It's also quite important in this domain. Like here, the noise is added to the federated learning environment, wherein I was talking about these clients, right? So the clients will be like sending the updates to a global model, and the clients are locally getting trained on the data available at their hospitals. So when they're doing the training itself, we can add this noise to the data so that the learning algorithms, even though they are injected with some corrupted data, that will be neutralized by this way. So in differential privacy, this random noise is added to the individual data point during the training, which reduces the impact any single data point can have on the overall model. And what is the mechanism here? So by adding noise to the sensitive features, this like pixel intensities in images or financial transactions, this differential privacy ensures that an attacker cannot reverse engineer the influence of any specific data point, and this makes it harder for the poisoned samples to like stand out or disproportionately affect the model's learning process. So next, the differential private stochastic gradient descent. This also I will give it an case study and also with an example. So this method is used during the training to compute the gradient updates that maintain the privacy. The gradients of individual data points are calculated with some added noise, preventing any single point of failure. Next to this, differential privacy ensures that this small changes in the data do not lead to significant changes in the model's output, and this makes this model more resistant to the poisoning kind of an attack. So it is talking about the federated learning on the mobile devices. This poison data. So if there is a poison data from one or two devices, it will not drastically like alter the global model's update, and then like it will ensure that the model is not affected in a larger scale. Next is a previous, we may be knowing these advanced different techniques like ensemble learning, wherein we go with the majority voting, and then like secure aggregation in the federated learning. There are also few some of the advanced techniques in this domain. So in the case of the ensemble learning, how it works is multiple models will be trained, multiple models will be used like instead of a single one. And these models are trained on different subsets of the data or trained using different algorithms. So the final prediction is made by combining the outputs of all the models, either going by the majority voting or by averaging, right? So this is a one way we can understand, okay, even though like there is a mismatch with one model, it can be nullified by the using of other model. Next is the bagging technique, that is the bootstrap aggregation, we call it as, wherein the multiple versions of the training data sets are created through resampling, or like people are nowadays using synthetic sample generation by using various methods. One of them is the GAN, right? Different instances of the data, and these separate models are trained on each subset, and their outputs are combined to make the final decision. Next is the boosting, wherein it is sequentially trained models, where each new model focuses on the weakness of the previous one, and ensemble of these models are resistant to the attacks, right? So in this, the advantage is if one of the model is compromised due to the poison data, or other models in the ensemble can counteract its influence, leading to more robust overall performance. Next is in the spam detection, probably like you may be seeing it, like when sometimes this labels are misclassified, right? Poisoned with mislabeled emails. Now, using bagging, these separate models trained on different data subset can ensure that the influence of these poison samples is diluted. Next is how does it work? Is secure aggregation in this predicted learning. Another thing is cryptographic techniques. So, like as I was telling, in the federated learning, this client will locally get trained on the data which is available locally, and then send the updates to a global model. Now, instead of that, can we use that homomorphic encryption technique and then encrypt the data at the client level itself, and then send the encrypted updates to the global model, so that the global model will run over the encrypted data and then like give the predictions. So instead of sending the data in the plain text and everyone coming to know what is happening, or there is a leakage, we can say that this secure aggregation with the help of the fully homomorphic encryption will work in a way such that this privacy is been preserved, and the data leakage is not there, and also the model is also not getting under the poisoning attack. So this ensures that the adversaries cannot tamper with the individual updates or identify the poison data based on the patterns. So secure aggregation protects against the poisoning attacks, right? So next is smartphone app, like we can see it. So spam detection poisoning is one way, wherein attackers attempt to inject the maliciously labeled emails into a spam detection model. So like in the case of the spam detection, how do the algorithm works is based on some labels, it will uh, classify them as a spam or a non spam, right? So the spam emails are mislabeled as non-spam, poisoning the training data set. So what will happen is, by data sanitation, this pre-processing and content-based clustering to detect these mislabeled samples, so that this robust loss function reduce the impact of the mislabeled data. So it results to a more robust classification algorithm. As in this example, wherein an attacker poisons a data set used to train the autonomous vehicle systems by inserting this manipulated images of the road sign, what we can do is misclassifying the stop signs as yield sign or speed limit signs. So outlier can be detected by using image-based anomaly to flag unusual patterns in the training data, so that the adversarial road signs are introduced in the data set to make the model robust. That means we can give the adversarial training so that the autonomous cars will become more robust to the poisoning attacks. Right, social media sentiment is another example you can think of. Healthcare diagnostics also we can do it. What in this case, an attacker poisons this medical imaging data to cause a diagnostic system to misidentify certain conditions. So this system becomes inaccurate in detecting the diseases like cancer due to this poisoned data leading to false things. So what we can do is we can apply some statistical tests and unsupervised learning to identify these poisoned images based on the pixel distribution anomalies. And also we can use the differential privacy in this case. In the smart home environment is also in the same way, like poisoning attacks on the federated learning is launched by one of the compromised devices. Like if you are having the doors, like can you unlock the doors based on the false facial recognition where the biometric system is compromised? So we can use the Byzantine resilient algorithm there, like filtering out the malicious updates by uh, enable client updates and excluding the outliers. Right now, the secure aggregation is using cryptography doing it, right? So now, as you know, this poisoning attacks are a growing threat across the industries, and then like multi-layered defense is the need of the hour, where the data sanitization, adversarial training, ensemble learning, and differential privacies are some of the strategies, and also like safeguarding these ML models is critical as they are applied to high stakes and real world applications. And ongoing research is crucial to staying out of this adversarial technique. Now, what I will do is I will just show you what is there in the. No, just a second. Okay. So, what I will do is I will just share with the examples. Here, what I'm having is a poisoning attack. I hope my screen is visible, right? Are you seeing a collapse screen on my screen?
Yes, sir.
Just a minute, let it be loaded, this collab model. What I'm trying to do here is, just a second. So this collab comes with the most of the libraries which are already like preloaded. One of them is NumPy, Matplotlib, and then Scalar. These are some of the things that do exist. And then like we can share this with the others so that they can also like download it and then they can use it. Just a minute, let this model be. Okay, I'll take other examples here. Okay. See here, what we try to do is we'll just try to see a simple poisoning attack, how it will drop the accuracy. So here, like what we have taken is some model. We have just used a data set. Like we have taken some 500 samples and like number of features we have taken into 10, and we have taken only two classes. One is binary classification. In between, like we will train on the clean baseline model, and then it will give the clean accuracy. Then we will try to like poison this models, like poison this data. What is the input rate is there, I will just poison it by 30%. We can change this values, and then we can see that once we do it, the model accuracy drops down. See here, when the model was giving, in the case of no poisoning attack, it was giving 88% accuracy. And then like when we poisoned it for 30% of the samples, the model accuracy burned down to 78%, leading to almost like 12 to 13% of down in the accuracy drop, or like we can say 10% drop. Yeah, right. Like, but here the challenge is like if we go on increasing the poisoning attacks here, just if you check, I'll just share this code with you all. Like you can just practice it. How we can see is if we go on increasing this poisoning rate, it will further like reduce the performance. Like for example, it was clean model is having 88% accuracy, whereas this has dropped down to 69 percent, where the accuracy is down by 20%. So each percentage of this adding this poisonous input in the data will lead to a significant reduction in the accuracy. So we need to ensure that this data points which we are feeding it to the model should be free from the poisoning attacks, or at least we should make sure that some robustness or some action has been taken so that the effect of this malicious thing has been uh, null or have been waived off. Right. What I can also do is I can share with this organizers with this code. So you can run on this code and then check how this poisoning attacks has been done, and then we can see it. So what we have done also, like on some part, we have used on Internet of Medical Things. I'll just show the and then share the GitHub repository also of this work. So as you know, this Internet of Medical Things enable this real-time healthcare monitoring. When I say Internet of Medical Things enable the real-time healthcare, means a patient is admitted to a hospital and then like he's having lot of data with him, like ECG monitor, different monitors, right? Now this will send the updates to a global model or a central server. But the challenge is like this central server may be subjected to a poisoning attack. So in that cases, like what we can do, right? Because as I was telling, like we are sharing the raw medical updates here, and then and we need to take care of the GDPR guidelines and different thing. So how we can come up with this in this model? I'll just go to the framework directly and then show it. See, this was the overview of the methodology. To overcome this poisoning kind of an attack, what was done here is like we have taken the CIC IOMT dataset and we did the data cleaning, feature engineering, feature selection as we do it with all the normal cases, and then resampling, data splitting. If there is an imbalance, we use the SMOT to remove the imbalance, and then we use the autoencoder to learn on the what is the malicious data. And then before giving it to the federated learning clients, we will use the differential privacy so that some sort of a noise has been added to the data before it learns over that one, right? And then this will be further given to the like classifiers for the classification, so that this adversarial training is done. And also we have made sure that the data leakage is also not there, so the poisoning attack has been overcome. And we can see that by using this like adversarial training, we are not losing out with the much performance. Only the drop is in 1%. Okay, only 1% data has been dropped in this case. And also like device level classification also for the ECG monitor we have tried, and then we checked with the differential privacy. Here also it was like the what do you say, the performance has been not dropped significantly. So per attack type classification also we tried to do it the global model with random forest. There also like by using differential privacy, the performance had not dropped out significantly. That means by using this differential privacy or the adversarial training, we can ensure that the model is still giving a better performance. That is there. Okay, so just these are the things like that do exist in this domain. So if anyone is interested, you can start working on it. Like I will share this slides and the code and the GitHub repository with you all, and how we have used this HDB scan for zero-day attacks. All these materials I will share it with you, and like we have some ongoing research work with in these domains, so you can read them, and also like we'll be happy to collaborate. Okay, so with this thing, like I'll just like to conclude it. If there are any queries, like please do ask so that I will try to answer them. Any queries from the participants, please feel free to answer. Feel free to ask. Any queries from the participants or I think. I'm audible, right? Am I audible or how is it? Okay. Chat option is not open or like is it? Research gap in healthcare, like there are a lot of open things are there that can be done in the healthcare. Like one is as I was telling, like this poisoning kind of an attack. If you're looking for machine learning or federated learning aspect, that is one way. And then like if you want to come from the medical image processing or image processing, you can do a lot more there also. Like so, if you can come up with specifically what do you mean by healthcare, then it will be easy to like answer these queries. Okay. Poisoning attack in the IOMT is like now this diagnostics part I was talking, right? Like if you are maliciously adding some data in the training process, and if a person who is having cancer or the possibility of getting cancer is classified as a person who will not get the cancer, then the model will get trained on it and it will give the same output, no? So now, can we use this machine learning adversarial training so that this effects of such things will be nullified. So, and also like probably when you can also see is multiple hospitals are involved, they are not ready to share the data with each other. But like, can we do the combined learning or distributed learning in such a scenario? Then if one of the hospitals data is getting corrupted, it should not affect the overall training process. So the model should get tuned to if one or two of the hospitals are corrupt or not giving the actual data. So that is one example in this case. So any other queries or anything?
Sir,
Yeah,
Bhavan sir,
please.
there is a question. What is the deep learning framework from Somashekar sir?
Deep learning framework in the sense like what kind of an architecture we can use to fine tune to your problem which you are working on. Like for example, you are working on medical image processing. How you are modeling, like how you are taking the models in that case. What kind of models are suitable to solve your problem? That is called as the deep learning framework. So we should think from a perspective of what is the problem and what are the tools to solve it. And this machine learning or deep learning as a tool to solve that problem. First, we should I prove a scenario wherein this problem can only be solved by using deep learning. Then we should use the deep learning networks like any of them, ResNet, MobileNet, or whatever that is suitable for this environment and use it. That is called as deep learning. That is called as a deep learning framework. That means fine tune it to the application.
Sir, there is another question.
Mhm.
Why use bias in neural network?
Okay. See, generally in the neural network, like always, whatever the model, when you're learning the patterns, right, the data will not be always linear. If the data is non-linear or like it is very complex, then what we try to do is this bias, we will add some sort of an extra parameter or like a constant we will use it so that the activation function can shift to left or right, making this model more flexible. So, like if you take this straight line equation y is equal to mx plus c, this c whatever we are taking, right? It is like an constant. So if it just take y is equal to mx, it will just take the straight lines which are passing through the origin, so that it may not combine all the real time data or which may not contribute to the real time data, because real time data will not be very linear in fashion. So that's why this bias is used to handle such things. How can we implement federated learning? Yeah, there is a Flower framework is there that can be used as a software you can implement on your local machine also. You can get some simple videos as well how to implement the Flower framework. Flower FL, if you like, if you type, you will get the whole website on how the federated learning is implemented using a Flower framework. So you can use it and then try to learn it based on the Flower one. Okay, FLWR or also FLOWER also it is called as. Right. Anything else?
Sir, there is a question from Bharati Madam. I have started my research in
Yeah,
neonatal.
tell me.
Can you suggest different sources to get data sets like Kaggle?
Neonatal in the sense like what kind of data in the neonatal? Sorry, no. What kind of problem in the neonatal? Whether it is on the skin texture because they're subjected to this jaundice kind of a thing, yellowing of the skin, or like what is the problem they are working on? Then you can see whether it is possible.
To early disease prediction, she has asked.
Okay. Earlier days, then you should try to get in touch with some of the hospitals which are pro in doing such sort of a research, because getting the data of neonatal is a challenging one, because even in the biometrics that's a challenge. So you need to get in touch with some hospitals and look for these problems, because simple problem data sets are in Kaggle, but very particularly like this yellowing of the skin and other things is not available. So better you can just look at any local hospitals or maternity homes so that you can have a non-disclosure agreement and try to get the data so that you can also make them as collaborators and you can work.
Sure, sir. Is it easy to get collaborated with them? Actually, I'm back to this side.
Yeah, you
And
can try. Like
is there
some of the
a...
hospitals.
Okay.
Only thing is ethical clearance should be there, like some sort of an non-disclosure agreement that the baby's name and parents' name should not be disclosed. Apart from that, like if you make that agreement, then getting data is quite easy. It's not that difficult.
Okay, sure. Okay, sure. Let me try rewarding it. Okay. Thank you, sir. Thank you for your suggestion.
Uh, Sir, there is another question. Difference between unstable model and overfitting model from Dr. G. Ravishankar Reddy, sir.
Okay. So generally, when we say it is an unstable model, right, there is a high variance in the data. There is a characteristic of an overfitted model, we can say. And in the other word, like this, what we can say is this generally, this overfitting model is inherently unstable. Okay, that's one way we can say it, because this is having like what you say high variance, and also it will be like complex generally.
I think that is the
This
last.
unstable model, one more way you can think is when you're getting training right on the data. If it is the model is unstable, then even there is a slight change in the input, right? Then this predictions will also change. For example, your LLMs, if you take large language models or ChatGPT, if you give some input, if you change one or two keywords, there will be large variations in the output given. That is an example for unstable model.
Is it a variation in predictions or in parameters?
Predictions will change. See, if you just the like parameters which you give as an input there, then there will be in the prediction there will be a huge change, because that's why this LLMs, these large language models are very prone to this change in input.
So does it mean the parameter, I mean the coefficient values are large, the model is always unstable?
In one way we can say that. So like, but these models, when I say like, but this, yeah, we can say that only.
So does it overfitting model always we can say the model is unstable?
Uh, Overfitting. Oh yeah, we can say that that way also. Because overfitting can also like make the model unstable. See, it's
Okay.
like both the way around. Like what do you say? Instability is some sort of an what do you say, behavior of an overfitted model, and the other way, this overfitting also causes this model instability.
How can you convert this unstable model to stable model?
That's why like we should train on an like a data set which is not biased towards something. That means the data set should not be imbalanced. To
Okay.
remove that,
Okay.
only this technique like SMO trend will be used.
Okay. Okay. Thank you, sir.
So there will like class imbalance will be nullified by creating some synthetic samples of these minority classes.
Okay, sir. Thank you. Thank you, sir.
Somewhere I can share you also like some data which may be there as a research article, and also in the last ICPR one of the keynote speakers had like had given a presentation on it, like how these large language models are sensitive to the input variations. Even a minor input variation like can lead to a significant change in the outputs, like in the
So
performance of the model.
that is possible when parameters are large.
It
Parameter
can be like,
values, values.
but the thing is like in what kind of application you are working is also important.
Okay. Yes, sir. Okay. Thank you, sir.
Yeah.
Um, and that might be the last question, sir. So participants, if you have any questions, post the questions in the chat box. Otherwise, you are unmute yourself. You can directly contact the resource person.
Sir, can you suggest one single textbook for UG students regarding machine learning?
Nowadays resources are many, sir. Like there's no
Mm,
single book which can make the students accessible, because earlier this Christopher Bishop book was there. Sometimes people think it is quite difficult. So there is no
okay.
single book I can say, but there are multiple courses and then like which can be taken. Or like Orile has some hands-on books are there that can be referred, because they will come with some example and then in Python, so that students will feel like it's easy to go ahead with Google Colab and other things.
Okay. Thank you, sir.
Or maybe better, what you can also do is now, anyways, you know, like which topic from where it may be easy. So you can create a list of resources in a Google Sheet and share it with the student. So topic wise, they can learn from the different sources.
But again, the notation is the problem.
Yeah, that's there. Maybe that you can cover in simple classes, or like sometimes you can take some lectures and help them out.
Yeah.
That is there. Like sometimes one fellow uses in some notation, some function, some will use in other. That's the challenge. But try with
Yes, sir.
Orelay this one. So like the hands-on, they're having some of them are good. I gone through them
Which one, sir?
because
Orally.
this Orelay, OREILLY, they had some hands-on kind of books are available
Okay, okay, sir.
that you can refer. And some of them are not available. You can request even authors; they will be happy to send you.
Okay, sir.
Because Tom Mitchell book, like earlier people are using it, but nowadays students are feeling it difficult to go through it. They require some sort of an hands-on. They feel the students feel.
Even driver haste is also highly complicated.
Which one?
Statistical learning, driver hasty.
Yeah, that's also is there because Christopher Bishop book, that pattern recognition, that is also people are feeling the same way.
Yes, yes. Okay, sir. We'll be in touch with you. Thank you.
Yeah, sure. You can drop me a mail. Like we can discuss sometime and then see like whether we can collaboratively come up with a Google sheet and then share it with your student as well as our students so that they can
Yes, yes,
like get
yes.
benefited. So my
Right.
email ID is there on the first slide, and also I will share with the organizers. You can take and write to me.
Yes, sir.
And also, if anyone is looking for some collaborative work or anything in these domains, you can please feel free to like write to me. My email ID is the same here, which is there on the first slide. PAVAN at IITDWD dot AC dot in. Also, if you are looking for some student internship or something, we can discuss. Yeah. Any other queries or anything? Yeah.
So no questions in the chat box.
Yeah. Okay.
Okay.
Fine, ma'am. If that is the case, then like we'll stop the. I'll stop sharing the screen, and then like if I'll share the materials post this session.
Yes, sir.
So
That
like
collab
share
link
with
also participants are asking,
yeah,
sir.
yeah. I will. Yeah, I will send it now. Okay.
Okay. Uh, Thank you very much, sir. On behalf of our Atal Academy and SNIST, I extend our sincere gratitude to you for delivering an insightful and well-structured session on this topic. Your session provided a clear conceptual foundation along with practical demonstrations, which enhanced the participants' understanding and their real-time implementation. We truly appreciate your time, effort, and willingness to share your expertise with such enthusiasm. Once again, thank you, sir, for your valuable support and for making this session a grand success. Thank you very much, sir.
Yeah. Thank you, ma'am. Thanks for the opportunity. Hope to see you all in one or the other venue in the future.